Hello, everybody. My name is Dr. Aamir Abbas, and I am here today with a series of sessions on R programming for analytics. And as we have been discussing on our WhatsApp groups, that this is going to be a very short series, and this is the first session in that series. Um, without Before getting started, I'm going to lay out some rules for this session. First of all, I will be giving you people a presentation on R Studio, and that is going to look like this. And I'm going to go through each the slides and the programming snippets or the code chunks in there. So here is how it is going to work. If you have a question which is pertinent to the point which I'm discussing, please write that down in the comments. And I have Dr. Hassan Nawaz Tahir, who have been kind enough to help me facilitate this session or help me conduct this session. He will be looking at the comments and letting me know or interrupting me if needed. So I will take those questions. There will be two types of questions. If the question is relevant to the point which I'm discussing, I will stop and just answer that question. And second type of question, which is not relevant to the point which I'm discussing, that I will take in the end. So just to give you an example, if whatever question you have, put them in the comments. And what we have, just to give you an example, for example, there's a question, I will project that in this way to the screen. And as an example, I will answer this question. That will you be saving this video? Yes, that video will be saved with the same link as you joined, and it will be available for later use whenever you want. So that is going to be the basic logistics related to the question. So the bottom line is that whenever you have a question, you just type them in the comments. That is the first thing. The second thing is what I'm going to do, the format of this presentation is going to be that I have some slides and I have some code chunks. I will be going through both of them in the same RStudio, which means that I will not be changing between PowerPoint and RStudio. I will have our programming, some instructions on some slides, and some code practices within the same window, and I will be, both of them will follow each other. So what I want you people to do, in case if you are able to follow up with me, then that is excellent. That is amazing. That's ideal, I would say. But in case if you think that you are not able to follow up with me, then still that's okay. I mean, don't sweat it. What you would want to do is just to focus on what I'm saying and try to understand the conceptual, try to get a conceptual understanding of what we are getting at. And later on, what you would want to do is to revisit this video again, and then I will share the same document in the form of a PDF document in the WhatsApp group, and later on you can also use them and practice them in your own time. And if you have any questions, you can we can continue with this discussion. So before we get started, let's hear from Hassan. Hassan, can you hear me? First of all, are you with us?
This session and for giving us this opportunity to learn R. So is there anything specific you would want from my end?
Yeah, just as I said, you just keep an eye on the chat and just let me know if the fonts are right or things like that, as we discussed earlier, right? Okay.
Sure.
Okay. So with that, I'm going to continue with the session. And as I said to you people, this session is on R programming basics, and to be specific, R is a programming tool. It's a language. And before we go into R, first of all, I have to talk a bit about what is a programming language and what is a language. It's very simple. For those who are new to computing, even the concept of language may be very unclear to them. So let me explain that in very simple terms. In computer sciences, there are different languages. For example, R, Python, SQL, Go, etc., Ruby, etc. And language is, for example, I'm talking to you people in English. So this is my language, and I talk to you people and you understand, and then you respond back to me. So it's a medium of communication. In the same way, when you talk to a computer, a language is something which helps you interact with the computer. So that is something which makes an interface between human being and the computer. So if you have to give some instructions to the computer and get some response back from the computer, you have to do that with the help of different languages which computer understand, and you learn those as well, so that human being understand and the computer understand. You give some instructions to the computer and get something back from the computer. So that is a very baseline or basic introduction to what a language is. And as I said, that there are different languages. R is one of them, Python is another of them, SQL is there, and there are so many languages, C++, Java, etc., etc. R is one of them. And what is specific about R is that it's a language which has been made by statisticians for statisticians. Other languages like Python or other languages, they're primarily focused on giving instructions in a way which computer scientists will understand. But R is a language which have been made by statisticians for statisticians, which means for research purposes, it has a lot of analytical diversity. It has a huge number of packages. It has a huge number of functionality, which we will try to explore as much as possible. And why should you learn R? So that is something we will try to go to in our subsequent portion of this presentation. So let me go forward over this. And so what happens is that R is a very, like you will ask a very basic question, that why should I use R as compared to Stata or SPSS or other SAS? So like there are three major software which you might have already learned if you are a public health professional, or you have done some level of training, you have undergone some level of training in different statistical packages or softwares. You might have either learned SPSS, you might have either learned Stata, or you might have already learned SAS. So you might ask a very obvious question: why should I take the pain of learning R? So here is a basic. There are a lot of reasons. There are a lot of reasons for that, but there are a few obvious reasons. First of all, very important, R is open source, which means that you never have to pay anything to anybody. That's one thing. Second is that the level of functionality which R has, the things which you can do with R, you cannot do with any of the other available softwares. So despite the fact that it's a free software, it has a huge functionality, which means that you can make interactive graphics with R. You can do a huge number of, you can use R to run from basic to intermediate to advanced and innovative statistical methods. You can make interactive graphics, and there's a huge list of things which you can do with R. So that is one of the reasons, because when you're talking about analytics, there is a discussion whether you should choose between Python and R, but definitely ideal is that you learn both of them. But if I have to choose between the two for analytics, I will choose R. So that is basically my personal recommendation, because of the diversity of the functionality which is present in R. Especially there are a few things which are very strong in R. Like I will give some examples in this session as well. In the end of when we reach towards the end of it, I have some demonstrations that include interactive graphics are very strong in R. There's something which we will not be able to talk about, which is a Shiny application which you can make in R. You can Google what is a Shiny application, but what a Shiny application is that what you can do is you can process your data in a way where the end user can interact with the dashboards and make any modifications to the data. So these are the kind of things which you can do with R when you are strong in R programming. Now, coming to the objective of this session, the objective of this session is just to introduce how programming is done in R. And the second thing is that I'm going to motivate you to learn R, because if I'm able to make you enter this universe of R, this R environment, then there's a huge opportunity for you to learn from internet, and we'll be continuing on this during these sessions as well. So before I get started, I will just have a look if there is any question. So what I will do, as I told you that I will also want Dr. Tyre to interrupt me, but after every 5 or 10 minutes, I will also see to the chat if there is any question, if there is anything which might need my attention or things like that. I do not see something so far. So as I said, if you haven't been able to download it, no problem. You just follow along with the session. Ideally, you should be able to like do whatever I'm doing. But if you're not able to do that, you can do it later at your own time, because I'll be sharing the PDF of this presentation with you people. So before anything, this is the R environment in which I'm doing the presentation. So if I give you a basic overview of R, like this will be something which you will have this, you will write the script, which means that your coding will go here. This in the bottom, we call it the console, and I will just increase its size if I can do that. Yeah, so this is the console. This one where I'm saying 2 + 2, that is where you will write your script, and this place where you will have all of your variables, and there will be some description. So your window will be divided into 4 portions. What I'm going to do for this presentation is I'm going to use something which is known as R Markdown, which is actually a bit advanced, not very advanced, but like it's very facilitative for running the sessions, and it divides your codes into different code chunks. But again, if you are not able to understand this thing, just don't worry about it. We will revisit these concepts later on. First of all, just focus on the subsequent slides which I'm just showing right now. Let me readjust my screen a bit so that you will be able to see it clearly. Let me decrease the size of this console so that you can focus on the slides only. And let me take the slides there, and let me now see if they're visible on the screen. Yeah, okay. So first of all, like starting from very basics, right? You can use, and this is something I would recommend, that when you install your R Studio or R basics, you should use R for these things, just to get a basic confidence of how R works. You can use R as a basic calculator, right? With the help of R, you can do addition, subtraction, division, multiplication. You can raise one number to the power of another number, and or there is a concept which is known as modulus in R. We'll be talking about it. So how does this work, right? Everybody knows how these things are. So let's go to how it works in R. And so, for example, talking about addition, very simple, right? So if I say 5 + 9 is equal to, I apologize, like there will be multiple times when I will be going back and forth between the window to increase or decrease the size of it. So until I get a sense of what works or not. Hassan, is this the right font, and we should go with this font, right?
Yes. We can.
Yeah, okay. So simple as that. Like as I said, that R can be used as a simple calculator. So when you say just write 5 and then put a plus sign and then like n, like whatever, it's very simple. And when you run this code, you will just have 14, which means that 5 + 9 is equal to 14, right? And the way to run a particular code portion of the code is to select that code and then press Control and Enter, and that will run it, right? In the same way, we can do subtraction. So again, very simple. If you have to subtract 2 numbers, here I'm subtracting 5. I'm subtracting 9 from 5. When I run this thing, then obviously the answer is -4. Similarly, I can do multiplication. Now here you have to remember, like for R, if you want to tell R to multiply one number with another number, you have to put the star in it. So what it's saying, what this code is saying, is it's telling R that take 5 and multiply it with 9. And when I run this code, obviously the answer is 45. In the same way, we can do division, and the division operator for R is this slash. like you have to remember that you have to you see the direction of the slash. For example, if I use this slash, then it will not work, right? It will give me an error. For example, if I run, you can see that it's giving me an error, and you can see this error sign, and even if I run, this is giving me an error, right? So you have to be using the correct direction of the slash, and you have to run it, and then like obviously the correct operator, and the answer is given to me. So this is division. Now here things become a bit I will not say tricky, but you have to be cognizant about that. And one thing I have to tell you people is like you do not remember these things when you're using R. It's a very common practice in programming that, okay, so let's assume I want to raise one number to another number. I want to raise one number to the power of another number, and I do not know how to do it. You will have to just Google that. And we do that all the time. Like, especially when you learn R and you learn Python as well, and like you have to be bilingual or you are using multiple languages, then it becomes extremely confusing because there are very subtle small differences in between the two. So you just Google them, and like you always have to Google, because it is very very easy for you to forget this thing unless like you keep programming to the extent that like it becomes a second nature. So what this code is doing is it's taking 8 and making it with this symbol, it's raising it to the power of 3. So it means that take 8, raise it to the power of 3. So and then you can see that 8 is raised to the power of 3, and the answer is 512. Now something becomes a bit trickier. If you want to get the remainder of a number, use the modulus symbol, which is this sign, which is 2 times percentages symbol. It will give you the remainder of remainder when one number is divided by another number. For example, if I want to divide 34 by 5 and get only the remainder, right? So then I will have to use this symbol, which is known as modulus. Okay, so if I run this,
Dr. Aamir, sir,
yes.
There are 2 questions. So the first question is, they're saying, does this respond, like, do you get the answer when you press enter? That is the first question. And the other question is, what's the meaning of 1 in a square bracket in console?
Okay, very good. So that's a very right. So let's go to the previous code chunk where I was showing you very simple operations. Are you able to see my screen? I think the screen went blank. Can you see my screen?
Yes, you can see.
Okay. Let's assume you want to run this code chunk, right? What you do is just select this thing, right? And when you have selected it, just press Control, and when you have pressed, when the Control key is pressed, along with that, enter. Press enter, which means that I will just type it over here. Is that what you need to do is do Control plus enter. So this is something which you need to do to run a particular code. So this is the answer to the first question, and the second question was, okay, let me actually project it over here. Yeah. So what is the meaning of this like the brackets around in the console? Is it represent the statement number? So what happens is that, for example, if this at this time, what I would say, just ignore this one. You will understand this when we come later to when you have more than one printouts, when they're printing out like longer things which have something more than one number. But at this time, you can assume that this is something meaningless. Just focus on this number and just assume that this is a output in isolation from this number 1, and we will definitely come back to this. So if there are no other questions, I will continue with the discussion related to modulus. Okay, so what I was talking about is that when I want to divide 34 by 5, and what my intention is to get the remainder, right? I do not want to get anything else but the remainder. What I would want to use is this symbol, which is known as modulus, which is actually 2 times percentages. So what I will get, again, I will select this code, I will press Control Enter, and I will get the answer of 4, which means that if you divide 34 by 5, the remainder is 4. Why would I want to do that, right? The reason I want to do that is like for I mean, like R provides you with a number of ways to manipulate numbers, and these skills come handy in different situations. So I will go back to the slide which I was talking about, and we just to see that you can use R as a calculator. And what I would emphasize is that you should start using R as a calculator and play with different numbers. Like take one number, add it to another number, subtract between the two numbers, do the subtraction between the two numbers, do division, multiplication, raise number to another power, and use this modulus operator. This, what it will do is it will give you some confidence on using the R environment, so that you can just like enter into this space. So again, let me see if there is any other question. So what is the backend? What is backhand calculation? I do not actually understand what the question means. If you can just explain the question or be more explicit about the question, then I will be able to answer this better. And let me move forward to the next portion of this discussion. Okay. Now, as we have talked about using R as a calculator, that's something which you should be starting off. Now, for example, we have numbers. I want to assign them to a variable. Say I have a number 10, and I want to assign it to a variable X. So what should I use? Obviously this one, which is equal to, I can say X equal to 10, and that is okay. I mean, there is no problem in that from a programmatic perspective. But there is something which our programmers prefer. There is no programming strength or weaknesses of one or the other, like you can use either of them. But the only problem is that if you have to work on an international level for some reason, if you have to share your code, then when you're doing programming in R, this particular sign is preferred, which means that this is actually the combination of less than and a dash. And for functional reason, both of them are equal. And what do I mean by this? So what do I mean by this is that if there is something, say the number 55, and in the R environment, I want to load it in the way that X is equal to 55. So what I will do, I will type X, I will type this sign as which is equal, which means equal to, and 55, right? So what it will do is that it will assign the variable X, 55 to the variable X, which means that if I print this out, then you can see that the result is 55. Okay. In the same way, there is, I want to do the same operation to the variable Y. What I want to say is that variable Y is equal to 55. So the alternative option is this, which is less than. This is the combination of two things. It is the combination of less than and dash. And you can find out, definitely you know the less than, and you can between the 0 and the plus sign in your keyboard, you will have the key for the dash key without the shift. So if this is known as an assignment operator in R. As I told you, just like when you're sharing your code, this assignment operator is preferred by the R community. And you see, when you see the code from any other person, you will see this used more often than this equal to. But for functional reason, there is no preference of one over other. So when I run this code, and when I run Y, and it's also going to give me 55. So I want you people to be very clear about this concept, because this is something extremely important and is one of the very simple but very basic building block of how one of the, I mean, you should definitely at least get this thing from this lecture going forward. So any question related to this? Yeah, there is a question, is that what is the reasons for its preference? I do not know actually, like why one of them is preferred over others. And to be honest, if you feel like you don't like it, don't use it. The only when I'm studying in our assignments, we have been instructed, we have never been penalized if we use equal to as compared to this other assignment operator. The only thing is that on international forums, if you are sharing your code with somebody who is an avid R programmer, or the second reason being, if you read somebody else's code and if you see this assignment operator, you should know it, because it is potentially confusing that, okay, at some places somebody is using this equal to, and somebody is some other place somebody is using this less than and dash. So both of them are equivalent, and there is no reason from a functional perspective to prefer one over the other. Okay, so how to initialize more than one variable in a single line? Yeah, this is a very good question, but I will just hold on to this question at this moment, because we are just getting started with very basics, and we will hopefully we can definitely do that and things like that. But at this point, we just want to get familiarized with the basic terminologies and basic assignment operators and things like that in R. I think things like that will come on in the future talks or the future discussion. Okay, so if I want everybody to be absolutely clear about this point, which means that if I use equal to or this assignment operator, they are equivalent. They are almost equal from, not almost equal, they're exactly equal. They're a mirror of each other. The only difference is that when you read somebody else's code, you should be knowing that this is the same thing. And if you share your code on an international level with the community, which is expert in R, then you should be using assignment operator as compared to equal. For your internal purposes or for your project, if you use either of them, that is fine. Okay, so since there is no question on this point, I'm assuming that this point is quite clear, because though it is a very basic point, it's a very simple point, but it is very important that you understand. And it applies to anything. For example, if I say over here as an example, if I say that x is equal to z, then it means that I've assigned z to x and so on. So whatever is on the left side, and if you have an assignment operator or the equal sign in between, and there is something on the right side, R will make both of them equal, right? So it is going to be applied across the board, and I'm going to use that all the time. So what I've done over here is that as a separate code chunk, as a block of code, I've also assigned z to the variable, the number 10, right? So now what I'm going to do, I'm going to combine the concepts. In the first part, what I did was I told you that you can use R as a calculator. In the second part, what I did, I told you people that I can assign different numbers to X, different numbers, for example, I have assigned a number to X, I have assigned a number to Y, I have assigned a number to Z, right? So what I can do that now, I can sum them all together and I can save them to another variable. So what is this code saying, right? I've initially assigned X equal to a number, Y is a number, and Z is a number. And with the help of the plus signs, I'm just adding them and just saving this to another variable, which is known as all. And I'm going to run this code, right? So what it has done, it has added X, Y, and Z together, and I saved it to the code. When I print it, I get the addition of the three, right? So this is very basic and very simple, but you can make it quite complicated, right? You can do all you can combine all the operations over there, you can add to number, you can subtract to number, and so on. So again, there is a question in the comments: what is a variable? Okay. Now the problem with very basic level questions is that it's very hard to answer them. But I would say, like how do you define a variable in algebra? Right? I do not exactly know that textbook definition of variable, but I would say that if you know basic algebra, for example, if we say if we in algebra we say let x equal to 10, right? So we are using variables in the same way as we would use in algebra. So that is a very simple answer, but unfortunately I do not know the textbook or algebraic textbook academic definition for variable. So if you are disappointed, I apologize for that. Going forward with this, now the next concept which we want to talk about is there are different types of variables in R. When you know the basics, how do we assign, with what types of operations we can do with R, and how we assign one number to a variable. Now we want to understand some of the types of variables in R, and these are not, and this is not an exhaustive list, but I've just chosen them to make it simple at this stage. First is integer, the second is character, third is logical, and fourth is factor. And I'm going to explain them to the code rather than talking about theoretically. For example, integer is something which is a round number. For example, 10 is a, like, you do not have any decimal points. There are round points. For example, if I say that the number of children, or say age of a person in years, or number of individuals, there cannot be round number. For example, if this 10 is a round number, definitely, then I'm assigning it to a, so this is an integer. Now my name Aamir, that is a character, because in Python we called it as string, in R we called it as character. That means anything which is like this text, and you just, and the thing which you have to remember about the character or string variables, in R we do not call it, we can call it a string, but like the type of variable will be character, and you have to assign, when you are assigning a character variable to this variable name, you have to put it in the inverted commas. So so what I'm doing is, first of all, let me run this. First thing, I've assigned 8 to 10, integer 10, then I'm assigning name, the variable name, to the character Aamir, and the third is Boolean operator. Okay, and Boolean is true and false. Like the Boolean, the variable type Boolean will have only two levels, either it's true or false. So if I assign the level true to this s, the variable s, and I run it, right? So now what I do, when I print a, I will get 10 because I assigned it to 10. If I print name, let me type name first, and let me just print it. It will print the name Aamir, and if I type s, it will print out true. So how would I know that which type of variable is each one of them? For example, a was what? A was assigned to 10, which is an integer, but I want to know what it is, right? Let's assume this a came from somewhere else. I didn't know. It came out from an operation, and I just want to know what class is it, and it's numeric. So why would I be interested in knowing the class of these integers or of these variables? Because there are some kinds of operations which can be done with certain classes as compared to others. For example, you can do some types of operations with characters, or some kinds of operations can be done with factors, some kinds of operations can be done with integers, and so on. So you need to be knowing what is the class of individual variables is. In the same way, if I go to the other variables which I discussed, and if I want to know what is the class of it, the simple function So let me also explain this. This is known as the function. Here it's, so if I generically write this function, what I will do is class, and I will open this bracket, and I will write whatever variable I want to know the class of. For example, A, right? I will put it in, and then I will run this code, and it is going to give me numeric. In the same way, if I run the second code, it's going to give me character, and the third one, S, it's going to give me logical. If I run this one, this is going to give me logical, because the class of the third variable was logical. And there were 4 types of variable which we talked about. I explained 3 of them, which is integer, character, and logical. And the 4th one is factor. And I'm going to talk about the factor variables in a bit, because there are some details which are not explained yet, to be able to familiarize yourself with the factor variable. Okay, so going forward, any questions so far? Now I'm going to go a bit faster, and if I can assume that you have understood this so far, that's okay. But if you haven't understood anything so far, you would not be able to follow along in the next portion of this talk. So please ask me question. Let me see if there are some question. It is something for which, again, I do not understand what is this question related to. So please let me know in more detail what do you want to ask. So alphabetical representation of a numerical value is variable. Interesting. Okay, and then Abbas is saying some computer science definition of variable is programming is a storage location of different data types. Okay, and then okay, so to be honest, I would just rely on this, because this is just I would say that from a statistical perspective, or from you just see how would you define a variable in algebra. Take that definition, and that's it. Okay, she's saying that she just explained the definition of variables, and let's go forward. So vector, what is a vector? Now, after understanding, getting an idea of different types of variables, let's talk about a vector. What is a vector? A vector is a sequence of data elements of the same basic type. What does that mean? For example, if you have numeric variables, a vector will have all the numeric variables. If you have character variables, a vector will have all the character variables. If you have logical variables, a character will have all the logical variables. And if you have factor variables, a vector will have all the factor variables. For example, say I want to make a vector of numbers from 1 to 9. So what I will do, like, if I say x equal to 1, then that is like I'm assigning only one number to this variable x, right? But what I want to do for some operation, I want to assign numbers from 1 to 9 to a variable named as numbers. So what I can do is I can use this simple operation, which is like, obviously I will type the name of the vector which I want to assign it to. I will use this assignment operation which I explained earlier, and then I will use this C. This is very important. Without that, you will get an error. Then you will open the bracket. You will type the numbers from 1 to whatever you want, not necessarily in sequence. Here it's by chance I've put them in a sequence, but they can be random, they can be ascending order, descending order, whatever you want. And then you run this code, right? And then, like, when you print it out, you have assigned numbers, this, say 1 to 9, the numbers of, like, numbers vector has the numbers from 1 to 9. Okay, in the same way, I have another vector where have all the character variables. For example, Sally, Maddie, Addie. These are the 3 names which I want to assign to the vector names. So in the same way, I will type the name of the vector. I will use this assignment operator. Then I will use this C, and then within the brackets. Now here, because it's a character variable, I will have each one of them in the quotation marks, and then I will run them. And when I run this code part, this will assign these into the names, and I will when I print it out, so the names vector has these 3 names saved to it. In the same way, the third type is, for example, a vector can be used to save some Boolean variable types. Let's assume true, false, as Boolean has only 2 levels, like just true and false. So what I will do, I will type out the answers as the name of the variable, this assignment operator, and then this C, and then all the values which I want to assign it to, which will obviously one of the 2, which is the true or false. I'll assign it to answers, and then I will run this code. And after running this code, I can just print it out, and like this answers will be printed out. Okay.
Dr. Aamir, there are a few questions.
Okay.
People are asking what is a character, then what is a class, and then so I'll ask one by one. So first is what is a character?
Okay. Okay. So I think this is the question. I want to know about character, logical, or class. What are you defining? So this is very important that you ask and understand these questions. And here, character is, for example, I will say in Python you call them a string. For example, you have some statement. Let's assume it's somebody's name, it's an address, or something else similar. That is something you call as character. Logical is a variable whose answers are in the form of yes and no. Sorry, not yes and no, sorry, true and false. That is a type of variable whose levels can only be true and false. That is logical. Class is like we have different types of variables, and we do not use the word type in R. We use the word class in R. So class is equal to the types of variable. For example, you want to know, okay, the answer is a vector. Answer has different variable. Answer is actually a vector. But if you go to the variables, if I go up on here, and let's assume like, okay, S is a variable, right? Or name is a variable, or so on, or A is a variable, right? Now I want to know what is A, right? What is, one thing is what actually A is, like what is contained in A, that's one thing. 10 is contained in A, okay. But now I want to know that what is the class of A, that what type of variable is A, right? Then that is numeric. In the same way, name, what is contained in name, that's one thing, right? Name has the word Aamir in it. So if I print alone name, then that will print out name Aamir. But if I have to find out the type of name, then that will be the character in the same way. I hope I clarified the question, because they are very overlapping concepts. If it is still not clear, please feel free to ask them again, and I will try to answer them again. Okay.
Just one question regarding object-oriented programming that is done in Python and stuff. So, is this class related to that in some way, like a class representing, like every variable is an object, and then the class is basically defining all the preferences of that object? Is that something like this, or is this totally different?
It's not that class as we used in object-oriented class. It's just say, I want to get the answer. Okay, I have a variable. What is the type of that variable? In R, one of the way to know that is to use this class function. Okay, so that is how you find out. And just don't go towards the object-oriented the classes in Python. That's a total different thing. So a simple answer is no. This concept and that concept is totally different, absolutely different. Okay. So then okay, there's another question. And what do we mean by C? Okay, let me go to that code part. Okay, So, okay, so the question is that when you have a vector, which has a vector by definition is something which have the same variable types, right? For example, all of them are numeric. Sorry, all of them are, yeah, all of them are numeric. And then when you are using these to be saved to a vector, you use the C. Now the question is, what is this C? I don't know. This is something which you have to use. Otherwise, it will not work. For example, let me actually try for you, and I actually do not know what will happen, but let me try. But it will not be saved as a vector, or it may throw an error, right? I exactly do not know what is this C is, right? If I run it like this C, it gives you an error. So if you want to save all of these, which are the same types of variables in a vector, and what is a vector? Vector is vector has the same variables, has the same types of variables. If you have to save them as a vector, then you'll have to use this syntax. See, and most of the times, some of the times you may or may not know exactly. There must be a meaning to this C. I actually do not know, right? If somebody else knows it, and let me know, that will be a learning exercise for me as well. But if you run this, and then you can see that all these numbers are printed out. Okay, so I think there were some other questions as well. A variable is any characteristic that can be counted or measured? Yeah, I think this is something, a very basic definition of variable. Okay, then Abbas is saying class is a function that gives the type of the variable. Yeah, that's exactly how we use class in R. A class is a built-in function in R. Yeah, class is a function in R. Right now, which we are talking about, it's the function in R. By built-in function, we mean that that's a basic function. In the later talk, we'll be talking about what is base R and what are other packages in R. So yes, this is a function. Thank you, Abbas, for clarifying this thing out. Okay. Right. Okay. I think there's something which I want to go to. Just bear with me. Okay. So what I can do right now is, let's assume I have different vectors. And as I told you people, that vectors will have the same, each vector will have the variables of the same class. For example, if there's a variable of the class numeric, then all of the elements or all of the members of the vector will be of class numeric, and so on, right? So what I can do all the operations which I have done on variables on vectors, because for example, if I can do addition, subtraction, division, or multiplication on those individual variables, I can do similar operations on the vector variable as well. For example, let me demonstrate this. Let's assume A is a vector, and as I told you that when you are making a vector, what you do is that you you type the name of the vector which you want to assign the values to. You use this assignment operator, and then use this C, which I told you that I exactly do not know, but it stands for, and then you put in all the members of the vector which you intend it to take, right? So when I run this code, it will assign A to these numbers, and the type will be vector. And then in the same way, I assign B to a vector, and when I print A, it will give 1, 2, 3, and when I print B, it will print 5, 6, 7, 8. Okay, so what I can do now, I can do element wise operation on them. For example, I can add the first element in the vector A to the first element in vector B. I can add second element of the vector A to the second element of vector B, and so on. How would I do that? Very simple. Very simple. What I can do, first of all, I can just write A plus B, and rather than going to the next stage, I would just say, let me start another code chunk for this. In here, I would just say A plus B, right? And that will give me the addition of the first element to the first element, second element to the second element, and so on. So first, 5 plus 1 is equal to 6. As you can see, you have 6. And the 6 plus 2 is equal to 8, and you have 8, and so on. So what I can also do is that rather than printing out all of them, I can do the same operation, right? I will say a plus b, and I can save it to another variable for later use for whatever purpose I need it later, right? So I will. So what is this doing? Is this variable all? This is not a variable. This is a vector actually, because it is the addition of two vectors, right? And then I will say all underscore add. I will. That is the name of the vector which I intend to make. I use the assignment operator, and as a repetition, I can use equal to, or I can use this assignment operator, which is less than or dash sign, and I can use the two vectors names, and I will say all underscore add, and this assignment operator a plus b. Okay, and then what I will do is and then print it out, and same result is printed as I did previously, right? In the same way, exactly in the same way, I can do all other operations, which is addition. This time I do subtraction, and I will get -4 because for all of them, because all of them are like when you do element-wise operation subtraction in the two vector variables, then you get -4 for all of them. In the same way, I can do multiplication, and I can save into this all multiply variable, and I get results of the multiplication. And in the same way, I can also do division. So the bottom line remains over here is that when you have a vector, you can do element-wise operation for each one of them. Now there are again some comments. Okay, so C. Okay, there are some answers from some of our colleagues. Thanks for Alias for saying C represents a one-dimensional array. Okay. Okay, what is the use of vector? So vector is also what you will do is you can make different vectors, and you can use it to make different you can do different operations with that. You can convert a vector into a column in a data frame, right? That is one thing. What is a data frame? I'm going to talk about in the later part of our discussion, but that is the basic concept. For example, what is a data frame? If you open an Excel sheet, individual, and you have data organized in an Excel sheet, in a spreadsheet, individual columns are there, right? And see that vector as a building block for that column, and you can convert, you can make different vectors in isolation, and then you can make a data frame from that. That is one use of vector, and there are many other uses of vector which you can see later on. Okay, and then this is in R array is also a vector. Okay, and there is something else. I'm happy that now the point is that I am also like teaching R is also a learning exercise. So it's good that people are commenting on this. C simply storing all these values in itself. So when you call it C, it will show you the values that are stored in C. Okay, maybe. Yeah, Abbas has something to add. C is a function, and we'll try and coerce it like list of elements to the same time if they are different. Okay, Abbas, I think let's not go into that territory because then it will be a bit complicated for our audience. But yeah, I understand what you mean. Okay, if this all is clear, let's move forward. If this is not clear, please ask me questions in the comments. Please do not let me go forward if it is not clear, right? In the meanwhile, let me load the next slide. Okay. So let me give you a very simple example. What we want to do is that there's a family where husband and wife works, right? There's a husband earnings and there's a wife earning, and I want to find out the family earnings, right? And what we are going to do is, so what is happening is that let me start with this first. We want to find out the earnings of husband wife for each month for 6 months. So I will have 3 vectors. One of the vector is this character. One of the vector has character variables, which are the names of the months for 6 months, which is January, February, March, April, May, and June. Okay, and then another vector will have one of the vector will have the wife's earning for each month, and the second vector will have the husband earning, right? So what I'm going to do, I'm going to run each one of them. I can run all of them collectively as well. That's not a problem. So I can select all of them. I can run all of them collectively as well, right? Okay. So what I can do is that I want to know that for each month, what is the total earning, right? So what will be the total earning? Now, husband earning is a vector, wife earning is a vector. Now, what I want to do for each month, I want to know the total earning, right? So I want to do element-wise addition between the two vectors, which is for the first month, for the month of January, I want to add the earnings of wife to the earnings of husband, and so on for all the elements of the vector. And what I can do is convert that into another vector, because when you add two vectors, the addition will result in another vector, and that is the total earning. And when I print out the total earning, right, let me show it to you. It's showing the addition of the element-wise members of each of the vector. So we'll have the first month's earning to the last month earning for each month. And returning to your question, Salima, what you said, that what you do vector. So let's assume what I want to do. I'm not going to show you the code at this moment, but one of the use of vectors will be that I want to convert this into a data frame, right? A data frame is just a data set where you will be able to do further analysis on it. So I can convert this information into a data frame where the column headers will be husband earning, wife earning, and month. For each month, you will get the individuals as well as you can have all of this information in the form of a data frame. Any questions so far? And when I'm waiting for question, I will just take a sip of water to give me a break. All clear? If there are no questions, I'll move forward. Okay, so the question is, and if we want the annual earnings and not the monthly, very good question. Okay, now I did not intend to do the calculations like that, but okay. So the question is that let's assume we do not want the monthly earning, but we want the annual earning, right? With this data which we have made right now, we will not be able to do that. But what I assume is that you want to do the total earning, right? Because we have this vector, which is showing the total earning for 6 months. So what I'm going to do is use this vector and calculate the sum of this vector and put it in there and just run this code. And I will get this total earnings for 6 months for the whole of the family. Now, what I'm going to do, in case had I just made the data for 6 months, but if the data was for 1 year, then if the same operation, you could have find out the total earning for 1 year as well. That's a very good question. Thank you. Okay, so now the next question is that for which months the total earning is greater than 6,500, right? And this is the application of the Boolean operators, right? Let's assume I want to find out, okay, we have the data for 6 months, and for which months the total earning is greater than 6,500. What I will do, I will just use this thing and see what I'm asking, or the question is that, okay, there's a vector which is total earning, and compare for each month, compare the element of the total earning with 6,500. And for each one of them, well, this is not right. I will just remove this part, okay? And just, oh no, that was right actually. Yeah, now I got why I put them, both of them together, right? Okay, so what this is doing is taking a number 6,500, and for each element in the total earning, it is comparing with the 6,500. And if it is greater than 6,500, then it is returning as true for that element. If it is less than 6,500, then it is returning as false. So if I print out the total earnings vector, so for the first month, the total earning is 300, so you have false for that, and so on. For the months which have more than 6500, you have true for that. You can see that, right? And this, the resultant components of this, we have not saved the result to any other vector, but if you save that to a vector, the components of that vector will be booleans. This data type is boolean, which is the result is true and false, right? So what I've done right now in the next step is to save the result to this vector, whether greater than, and whether greater than 65. That's what I mean. And when I print the elements of that vector, then it gives me true and false. Okay. Yeah. So there is another question: how do you place months against earnings? That's a question. That's a very important question. As I told you, that if you want to combine them in the form of a data frame, which I'm not going to do at this stage right now because we have not talked about the data frames, but you can convert, you can kind of combine them into a data frame and then do different analysis in that, and that's how would you be able to make combine them into one data structure. Okay, how long this session is going to go? It's going to go around this is meant for 2 hours, so we are 1 hour down the line, and we are, I think, will continue it for 2 hours. Okay. Okay. So again, as I told you, people, that since once you have saved them, the vector elements into one of the, you can do different types of operations. For example, you can find out the mean of the husband's earning. You can find out the standard deviation of the husband earning, and how you do that. Like this is a mean function over here. And again, this is, so let me explain another point over here as well. There is a concept which is known as base R, which means that when you load R, all of this functionality will be there. And there is something which we will be talking about packages, which means that some of the functionality will be not there in the base R, and you will need to install different packages to load those functionalities, and that will not work on base R. But mean is the function of what, whenever you are using a function, ask yourself the question whether that is in the base R or that is in the package, and you will know with experience and when you're using different types of R code or literature, that if some of the function is in the base R or some of the function is in the some of the package which is not present in the base R. But mean function is present in the base R. So for example, this is the function, and I just need to put in the name of the vector inside that function, and I will get the mean of this vector. So I get the mean of the husband earning. In the same way, SD is a function, and if I put the name of the vector in the SD function, I get the husband earning, standard deviation of the husband earning. And another important point about this function is that let me explain the construction of the function as well. So this portion is known as the name of the function, which you will call the function. Whatsoever goes inside the brackets, that is known as argument. For example, this is husband earning, which is going inside the brackets, that is known as argument. So some of the function will have one argument, and others will have more than one arguments. Some of them will not have any arguments, and so that is something which you will experience as you go along with practicing different aspects in R. In the same way, I can find out the mean and standard deviation for wife's earnings. Okay. So now I talked to you people about another variable. If you remember that we were talking about different types of variables, I said that there is another variable which is known as factor variable, and I did not explain it at that time because to get an idea of factor variable, you first need to have an idea about what is a vector. And now since you have a vector, then you have an idea about what is a vector. I can better explain what is a factor variable. A factor variable is another name for a categorical variable. If you understand what is a categorical variable, you will definitely understand what is a factor variable. For example, for some set of patients, I have this information whether that patient is positive or negative for hypertension, right? And how I find out whether the person is positive or negative for hypertension, I use this Y or N, where Y is yes and N is no, right? And in the same way, I will make any other factor. I will just save it to the vector hypertension, right? So what is this code doing is taking the information on a number of individuals on their hypertension status, stating whether they are a positive for hypertension or negative for hypertension. If they are positive for hypertension, it's saying as yes, otherwise as no, and saving it to the vector hypertension HTN. And when I'm printing it, it's just going to print Y and N. And now, as I told you people, what is the type of these variables? Such a type of variable is known as factor variable in R. So this is something which you need to remember. In other words, in plain simple words, factor variables is another name for the categorical variables. Okay, so let me see. Okay, so there are other questions. Is it possible to add parts of the earning? I do not understand what do you mean by this question. So I will see if you can just ask me again by more clarification how to get the earnings of the husbands for the month July. Very good question. Okay, but that is again, Abbas, your question is a bit advanced. Let's hope we are not going to talk about indexing and other those concepts. So I'm just going to give it a pass for it. It's a very good question. And for those who want to know about it, how you have to go into the concepts of vector indexing. Okay, so again, this is Danish's question. It's again like similar to his question. If, for example, I just need 2 months total earning for the couple. Yeah, again, this concept pertains to indexing. We are not going to talk about indexing in this session as well. Okay, and then Salima is asking, how is factor different from character? Very good question. Very good question. So, right. This is, let me think how to answer this question. Character is, say, when you're going to process the two, for example, if you have addresses, right? And address, there is a column or there is a vector for addresses. The individual address will be a character. That will not be a factor, right? Or if you have somebody names, that will be a character, right? But if you have something like a qualitative variable in the form of, say, yes and no, or whose responses are out of options from a given set of choices, then that will be a factor variable. So this is a very important distinction which you have to make, and this is also important when you get the data set. At the majority of the times, you will get the factor variables as character variables, and you have to change the factor variable. You have to coerce into factor variables. Sorry, you will, when you get the data set, you will get the factor variables as character variables, and you have to change them into factor variables. I hope I am able to communicate it correctly. If not, just ask me the question again. Okay. So as I told you that, yeah, okay, I forgot that I have this point explained over there. So if I'm asking the class, it's giving me character, right? And but I just don't want you to be a character variable, because this is a factor variable. So I have to coerce it to, or have to change it into a factor variable. And if I want to change it to a factor variable, what I do, I use another function which is known as dot factor. I use that vector or that variable, and both of them will work, and use this code to convert the hypertension into a factor variable and save into another. You can save into another name, or in the same, you can just change the same vector by just assigning back to it its own self. And now when I run the type of it, now it's saying that it's a factor variable. So in summary, when you get a data set, you will have all the variables which are supposed to be factors as characters, because they are imported as text. But with this piece of code, you will have to coerce them, or you have to change them into factor variables. Okay, so Salima is saying understood categorical variables. Yes, okay. And then what is she? It means R does not understand automatically factor. Exactly. So when you so it depends. For example, if you import a data set from maybe which have been pre-processed in other softwares like Excel or say SPSS or SAS, where it has been automatically coded. In some of the cases, you will get them correctly classified into factor variables. In others, it will not. But will have to manually check different variables, and where needed, you will need to convert different character variables into factor variables. Okay. Now moving forward. Okay. If you have any questions, feel free to ask me. And then once you have these factor variables, you can use this table function to run what we simply call as the frequency of a variable or a vector. And this will give you, so the table function, what it does, it's something which we in SPSS or Stata or SAS, it's just finding out the frequency of a variable or of a vector, not of a variable. Obviously, when you have a variable, you have only one value. Variable will have one value. For example, if it's a vector or if it is a column, it will give you the frequency of that thing. Okay, right. And let's move to the next portion of our discussion, which is less than, greater than, equal to, or greater. So there are some comparison operators in R, right? And when we use one of the comparison operators in the previous discussion, and that is less than or greater than, and like you have to use these specific symbols when you are asking questions for comparison of one thing to another thing, and you will use less than or greater than or less than or equal to or greater than equal to symbols to find out the answers to this. For example, let's assume I think X was already assigned to a variable 10, and if I want to check that, I will just before explaining this, let me see what X is assigned to. I will just type X and print it. Okay, so X is assigned to 1. So if I want to check, sorry, in this code I have assigned X again to 10. So I have assigned X to 10, and now when I print X, it will return 10. So now I want to check whether X is less than 10 or not. And the result should be what? X is not less than 10. X is equal to 10, right? So the result is false. And again, if I want to check X is greater than 10 or not, and again, the result should be false, right? So the result, as you can see, the result is, again, if I check whether X is greater than 10 or not, the result again is false. But because X is equal to 10, so the result of X less than or equal to 10 is going to be true. The result X greater than or equal to 10 will be equal to true as well. So these are some basic Boolean operators. So comparison operators in R, and there are two more important comparison operators. If I want to check whether X is, as I told you, that X was assigned to, so there are two things. One is if I say X is equal to 10, now these two lines of code are doing two different things. What this code is doing is making X equal to 2, right? Which we already assigned. I do not need to run it again. But what this is doing when you have 2 times equal, this is asking the question whether X is equal to 10 or not. And as we already have assigned that X is equal to 10, then this will definitely return true. And let's assume if X was another number, then it will return as false. In the same way, if now this code, the second operator is asking the question whether X is not equal to 10, right? But because X is equal to 10, then when I run this code, it will return as false. So let me see if there are any questions. Okay, so vector is a list of homogeneous data types. Can we say vector is a list of same data types? Now the list is another data structure in R. So I'm not going to use the word list, but the entities inside the vector will be of the same data types. Yes. Okay. So Kashif Ali is asking, can table function be applied for vectors with numeric and logical? Yes. Table function can be applied for all the vectors. Yes. Okay, obviously asking the question, and factor is list of items having different data types. No, no. I will be cautious about using the word list over here, because list is another separate data structure which we are not going to talk about this. But right now the answer to this question is, and factor is list of items of different data types. No, factor variable will have the same data types. Rather, within the factor variable, each individual items, the factor will be saved in the form of a vector, and within the vector, the individual entities will be the level of the same variable, or not the variable. It will be the levels of the same vector, or in some simple words, you can say that factor in R is just a categorical variable in a data frame or a column, or in another. Say if you have a column, let's assume male or female. When you save that thing in R, that will be in the form of a factor variable, and that you can save in the form of a vector. I hope I'm able to understand. I'm able to communicate this thing correctly. If not, please ask me the questions again. So now we go to one. We All this discussion was intended to reach to this point, uh, which is the data frame, right? We obviously, these data structures which we talk about, they are the building blocks, but our main interest is in something which we call as the data set. In R we call it is the data frame. And so just as a formal textbook definition of a data frame is, a table or a two-dimensional array like structure in which each column contains values of one variable, and each row contains one set of values from each column. It's a bit complicated. I mean, it is not very complicated, but it seems a bit verbose, the definition. But simple as that, let me explain with example. If you have a data set, it is known as empty cars, and this is again loaded in the base R. If you have R installed, you'll have this variable in it uh, by default, right? And you can there are some data sets which are there in R by default, and you can play with them to understand different concepts, and empty cars is one of them, and it's a database related to different cars, right? So first of all, when you get a data set, you can do a few things with that, right? uh, One thing you can do it is just write the name of the data set and just like run it, the code, and you will get the elements of the data set printed like this. But this is not something which I would recommend you to do, because it will, if a data set is very long and things like that, and things may get a bit complicated, um, uh, you may you will run you may not get a very pretty look of the output. So a better way to do is to just use head function and use the name of the data frame as an argument. And what it's going to do, it is going to print the first 6 rows of the data set, only the 6 rows by default. If you just use the default way to run the head function, and it's going to do, it's going to give you a idea about what are the different variables or the column names, and what is the structure of the different data of the data set, right? Here we can see that there is mpg, this column name, disp, hp, etc., which I do not know what does it mean, right? But I just get an idea, okay, these are the names of the variables. And what I want to do, if I want to like increase the number of rows, I can add the argument of n equal to whatever number of rows I want. For example, if I want rather than first 6 rows, I want 10 rows, then I can just run this function with which is essentially the same function, but the number of rows are increased, and we can see that I have 10 rows rather than 6 rows. Okay. Second way which we can use, we can see the structure of the data frame or the data set is to use this str function. So what is this str? This is basically, it stands for structure. And just what you are going to do, you have to just put in the name of, I'm sorry for this. Sorry for this. Okay. I'm going to put in the name of the data frame inside this argument. and what I will get is the structure of the data set. Okay. So what it is happening then, when I print the same, when I run this function for this data frame, it's telling me that, okay, the type is data frame. That's the first thing it's telling me. It's telling me that it has 32 observations. It's telling me that, which means that there are 32 rows in total. That's what it is telling me. Okay. And in the same way, it's telling me that there are 11 variables. So in the first line, I'm getting some basic information. The type of the structure is data frame. There are 32 observations and there are 11 variables. This is the basic. Now it starts to tell me about information about the individual variables. The first variable is MPG. It's of the type numeric, which means that the elements, okay, we talked about the type of the variable, right? So what does this mean? That individual, like this 21, this is of the type numeric, this is numeric, and so on, right? In the same way, so on, these are of the type, like this is quantitative. That's what it means. Like whenever you see numeric, that means it's quantitative, and so on. Like you can see the type of each variable. Somewhere it will be characters. Right now, this data set of all of the variable types is numeric, but somewhere it will have characters. Some will have the variable type as string or things like that. So here you can see the structure of the data frame, and some of it will also print out some of the values for a few of them, so that you can get an idea, okay, what is there in them. Okay, now if you have any question related to whatsoever you have talked about data frames, please ask me in the okay, can you explain one more time what exactly do I need to explain? Seema, please be specific about what do I need to explain about. Okay, I'm happy to explain, but if you can tell me what exactly are you not clear about, I'm happy to go back to that point. Okay, so now I have this data set inside R, but I don't know what is different variable. For example, I do not know what does this mean. What does this mean, right? So I'm going to give you a very basic learning to learn skill for R. If we have a function, let's assume, like rather than talking about this data set, we also talked about another function which is known as mean, right? We used it earlier as well. So I do not know what does this mean is, how to work with it, right? What I can do is I can just use the name of the function. I remove these brackets. I can use the name of the function and just type in question mark sign before that and just run this thing. And what is going to happen? Okay, it is going to give me, okay, right. Okay, so what is happening in this portion of your R Studio? Yeah, let me increase the size of it so that I can just show it to you. Okay, so you will get the description of this mean. When you run it with question mark, what is this function, how to use it, what are the arguments, and a lot of details related to that function. And this is something which works for almost every function in R, right? You don't know anything, just write question mark before that very function, and you will get a lot of data or a lot of information related to that function inside R. So because empty cars is a data set inside the base R, so they have description for empty cars as well. So I'm going to do the same thing. I'm going to read question mark and write empty cars, the name of the empty cars. What I'm going to get is the description, which is the name of the data set, motor trend car road tests, right? It's a description of the data set, which I at this time do not need to go into the details of. And what I'm interested in is that individual column names. Okay, these are the column names. Okay, and so you can see that you will see when we went through the structure of the data set, we just saw these column headers, which is MPG only, right? But you will ask the question that what is MPG? So it is mile per US gallon. In the same way, for each one of the variable, you have the description of them, which is very important for you. And again, for some of the variables, see over here, like you have that this is categorical variable, and it has the levels of it, but here you can see it's not listed as a categorical variable. WS is listed as a numerical variable, so if you have to process, you have to change that into a categorical variable. So these are the basic things which you need to understand while processing a data set. If we are any questions, again, you can put them in the chat. Let me just readjust the screen so that I can focus on the code screen. I'm having a problem in moving that towards that direction. Please bear with me. Okay, so this is a simple trick which you can keep on learning if you are stuck on any aspect of R. Let me see if there are any questions in the chat. Okay. So the question was, kindly if you can explain data frame functions head. Okay, happy to do that. So let's assume the concept was that I get a data set. This is empty cards. And I will explain it later that in your real practice, this empty cards is automatically loaded beforehand inside your R environment in the base R. This is a part of the base R, but before reaching to this point in the real world, you will have to first of all load the data set. And I'm not explaining that loading part in this video, but I'm assuming that for this description, you have already loaded the data set. So once you have loaded the data set, you want to see what is in the data set. And one way, for example, in Excel or in what we will do in Excel, you will just open the sheet and you would see everything in front of you. And same, you can see the spreadsheet form in the form of in other softwares like in Stata and in SAS, but you want to see how the data looks like, right? So you would take this function head and you would put the name of the data frame inside this head as an argument and just run it. So what it will do, it will give you some information. First of all, it will give you the first 6 rows. It will print out first 6 rows of the data frame for you, which will have the information on the names of the variables, as well as the how does the rows look like and things like that, right? And I can go forward because this is not coming in one of the screens, so this button will help you navigate forward to backward. And if you want to print more rows, you can just use this n equal to something argument, where something will be the number of rows which you want to print out, and then if you run this one, you will have that many rows. Here we have 10 rows that will be printed out. Okay, so the next function which I explained, if we want to see the structure of the data set, you run this str function and you will get the structure of the data set. They will explain the type of the data structure, which is the data frame, which is the name of it, which is the technical name of a data set used in R. It is saying that is 32 observations and it has 11 variables. Okay, so I hope that particular point was clear. And if it is still not clear, I'm happy to answer it now or later, but whenever you ask me the question again. And I talked about the structure. I talked about the how to find out the more details about the data set, and I'm going to move forward. Okay. So the main point related to this this description is that whenever you get a data set, you need to know, first of all, see the data set, right? So you have a few options, which is head is here. You can see the structure of the data set, and you can see like if the data set is the part of base R or any other package, then you can use this question mark and the name of the data set. Another thing which you can do is very simple, as because we are kind of obsessed with seeing the data set in the form of a spreadsheet. So I can also use this function view with one thing is very important, which I forgot to mention. R is case sensitive. What do I mean by case sensitivity? Whatever I'm typing, if I just type like I increase, I use capital MTRs, then it will run an error, right? It will not recognize it. So, okay, so it's kind of, so it's giving me a direction, but it didn't run it because it wants me to use the same case as there in the documentation. So we will have to be very much careful about this. Otherwise, you will get into trouble. So what I'm going to do is going to use the function view with V as capital and put in the data frame name and just run it. And what it's going to do, it's going to open the data set in the form of a separate spreadsheet. So this is the way we are used to be looking at data sets in our Excel or SPSS or Stata or SAS. Like we are used to be looking at data sets like this. So if you are like, you want to see a data set like that, what you do is use the view function. It will open another window for you, right? And you can just have a look at that, and then you can close this window and then come back to your original field, your original code window. So that is another way where you can see data sets. So moving forward, I will talk a bit about functions and packages in R. And one thing which I told you people is something which is known as okay, I just did a mistake. Okay, one is known as base R, right? And another is known as packages in R. So base R is some kind of a functionality which is present in the basic R, which means that you do not load any function. You just install R and RStudio, you will have those functionality. But there are a lot of functionality. It's a huge universe of functionality which is present in which we call as the packages. And again, the technical, I'm not very good in definitions, as you would have guessed right now, because I was kind of confused with a few definitions. I'm just like, I think that it works better when you explain by examples. So, but again, just when we are teaching something, we have to put in definition. A package is a package bundle together. If you want a textbook definition of a package in R, here is it. And a package is a bundle, something which bundles together code, data documentation, and test, and is easy to share with others. So in other words, in simple words, package is a functionality which is adding over and above the base R. And there are about 14,000 packages in R, which are growing every day. Everybody, you can make your own package as well. So if you want, and that's one way to showcase your work. And one important package which we'll be talking about today is known, it's a very, very good package. And it is the go-to package if you cannot kind of in this era, if you're working in R, this is something which you cannot go away from, which is known as the Tidyverse package. And this is, again, like everything in R is open source. Obviously, you do not need to pay anything for it. And the good thing about Tidyverse package is that it is a combination of many other packages. So either you load each one of these packages, or you just load the Tidyverse package, and that all of these packages will be loaded for you. Okay. So moving forward, one thing specifically about packages, and again, one thing specifically about R code, if you want a portion of your code not to run, right? Or if you want to explain your code, for example, sometime I will try to add some description like talking about packages in R. Now this is something for somebody to understand my code, right? I want to just put in comments. Now, when I put in this hash key, this pound sign, this will not run. Whatsoever after this line, the whole of the thing will not run. It is just a comment. So this is one way. So what is happening in this, if I just remove this pound sign or a hash key, it's going to run. And when you have when you're using a particular package for the first time, you'll have to install that package. So in order to install that package, you have to use this function install.packages function, and inside the brackets you have to put the name of the package. Important thing is to note that you have to put the name of the package inside of the quotation marks. If you do not do that, this will give you an error. If you run that, I'm not going to run that because it's going to take some time. You have to do that, and it will install your packages, and it's automatically as if some of the bars will be running as there is an installation process. And once you are done with the installation of the packages, then you will, the second thing is that you have to load the package. Now, installation of the package is something which you have to do once in your computer, and the second, whenever you close it, you do not need to install it again. And next time you have to just run it. You have to just load the library. So to load a package, you just need to use the library argument, library function, and the argument will be the name of the package, this time without the quotation marks, right? So, and then you will just run it, and that will be loaded. So what I'm going to do is I'm going to use this library package, this Tidyverse package, and there is another package which is known as Gapminder. That's also I'm going to use. I've loaded these two packages. Okay, so what is Gapminder? You must be aware about Gapminder. It's a famous data visualization platform, and this data set is from there. And what this package does, the Gapminder packages, it loads the Gapminder data sets. One of the things which it does, it loads the Gapminder data set. And as I said, whenever you load the data set, first thing you need to do is to see the head of the Gapminder. As we can see that this Gapminder data set has these columns: country, continent, year, life expectancy, population, GDP, and there are many other columns in that. In the same way, I can, as I said to you people, that I can also, if I want, I can use this structure function, and it will give me the different types of, when it runs, it gives me the types of the table, what is the data set. Now this is telling me that the type of the data structure is table. I'm not going to explain what a table is, but just assume that it is the same as data frame for the time being. And then it's going to give me the names of the individual columns. Here you can see that because it was already processed, it is loaded as in the form of a factor variable, where the names are the countries and so on. So it is going to give me some details of the individual variables. And okay, so another way to see a data set is also a glimpse function. It works similar to the str function as well, and its output is also similar, a bit different. You can use whichever one you prefer. And as I told you, if you want to see the data set in the form of a spreadsheet, you can use the view function as well. So that's the third thing which you can do. Okay, so now we come to the main thing. This is the data set, which is the Gapminder data set, and it has this many columns, and these variables, the column are the variables, and we want to just play with it, and I want to demonstrate something related to this. And then Salima is again asking a question. Let me see, what is she asking? Is it that different packages have different kinds of data sets, or the opportunity to program the codes? Each data set, each package is unique. Some of the packages will have data sets, some of the packages will have functions. So it's just like adding some functionality to your R, base R, and you will get to know this. Each package is different from other. Some of them have data sets and some of them do not have data sets. So this is a simple answer to your question. And going forward to this is that what we are going to do right now is we are going to play with this data set, which is the Gapminder data set, right? And first of all, what I want to do, let me go again to this view of Gapminder data set. And what I can see that I have a column which is named as country, which means that I have information on different countries in this data set. And what I'm interested in is to get the information only for Pakistan. Okay, so what I do, I mean, in other words, what I'm interested in, because a row has information for each individual countries for different years, right? And I'm interested only in information relevant to Pakistan, right? So in other words, I want to limit the data set where country is equal to Pakistan. So what I can do over here is to use something which is known as filter. Okay, so let me, rather than talking about this code, let me just go through step by step what it is doing. So I will use something which we known as filter. That is a functionality which is present in the Tidyverse function. Tidyverse package. Okay, and in the Tidyverse package, we have something filter. And when you're filtering something, let me just hide that thing, the code chunk below that. And so the first thing which you need to give to the filter function is the name of the data set. That is the first thing which you will give it, right? The second thing which you need to give it is the name of the column which we are interested in, which is, in this case, we are interested in country. And the third thing which we are interested in is, now you will say whether the country is, ask the question whether the country is equal to Pakistan, and you have to put Pakistan in the quotes, right? So what it is doing, it's saying that take the gap-minded data set. From the gap-minded data set, take the country column, and from the country column, limit it to the rows where country is equal to Pakistan. And you have to remember that you have to use these 2 times equal signs, because what it is doing, it's using the gap-minded data set, taking the gap-minded data set, from the gap-minded data set, asking the question whether country is or is not equal to Pakistan. If the country is equal to Pakistan, then it is going to filter on those rows, right? So if I just leave it here and just run it, what it's going to do, it's going to just print out all those rows which have country equal to Pakistan. And let me do that actually, right? So here you can see that all the rows where the country is equal to Pakistan have been filtered out. So that's not what I want to do. I just want to save it to another data frame, which I can manipulate or do some analysis on later on, because if I leave it as such, it will be just printed out and nothing else will be done. So what I want to do is just to use another name for this. So within the gapminder, I can give this data frame another name, and I just assign it to the same code, right? So I will just, the following code is exactly what I did right now. So I'm going to remove that. And so what it is going, it's whatever data frame I got it over here, I'm just going to assign it to this new name. So we'll get the same data set filtered and assigned to another name, which essentially will make a copy of the reduced data set. And I'm going to just, again, as we will get any data set, I will just going to run the head of it. Just run it. And you can see that you have the new data set has rows limited to Pakistan. I hope this point is clear. And if it is not clear, as always, please do not hesitate to ask questions. Okay, so in the same way, I think I was intending to go into some data visualizations as well, but because I think I am assuming that it is already got overwhelming, so I will just talk about a couple of more functions. And if you have any questions, please put them in the chat, so that as I'm talking about these 2 functions, I will and then answer them in the chat. So the second thing which I want to do is, let's assume we are interested not only in Pakistan, but we are also interested for data for some years in Pakistan. Like, let's assume I'm interested in the gap-minded data set for Pakistan for, say, a particular year. So I can also use the same filter function. And here what I'm going to do is use the same filter function. And so this is the filter function. And I'm going to take the gap-minded data set, and from the gap-minded data set, take the country and check whether the country is equal to Pakistan or not. And the code, because is going to the second line, but that's okay, because that's going in continuity. And I'm going to add another argument as well. So and is going to say, check whether it is equal to Pakistan, whether the country is equal to Pakistan, and for each row also check that whether year is greater than 1960 or not. So, and I'm going to save this data frame to the name data framed gapminder Pakistan after 1960. So now if I save it and I run the head, I will get the rows for Pakistan after 1960. So that's, you can see that the country in all the rows is Pakistan, and year is greater than 1960, which is 1962, 1967, and so on. So okay, let me see what happened. Just a minute. Okay, in the same way, I can also find out, for whatever reason I want to find out the data for Pakistan and India from the gapminder. I can say that use the filter function, take the data set, and use the country variable and add check whether the country is Pakistan, and this vertical, this symbol is for or. So I'm asking whether the country is equal to Pakistan or the country is equal to India, and then save it to Pakistan, India, and then print this data set, or find out the head, print the head of this data set, and this is giving me the data set for Pakistan or India, right? And so on. I can just filter on multiple conditions in the same way. So this is, I'm going to move forward in the interest of time. And one last thing which I want to talk about is how we talked about selecting rows. If we want to select some of the columns as compared to others, for example, if again in this, I'm interested in the country, some of the columns and not all of them, but I can use I'm interested in country, continent, year, and life expectancy, or some of the columns and others. So what I can use is the select function from the Tidyverse package. And what is that? And I'm going to so I've used a bit complicated version of that where I've explained the pipe operation over here, but I'm not going to do that. I'm going to just explain the way I did it in the previous code chunk. So let's assume I have to select some of the columns. So I'm going to use the select verb or the select function. I'm going to type the name of the data set which I'm interested in. And I'm going to, what I'm going to do is I'm going to type in the names of the columns which I'm interested in. Say I'm interested in only country column, right? So I think I might be running into some error over here. Okay, yeah, no, this is not how it works. So for me to explain it, I have to explain the pipe function before that, which I will do the next time, hopefully, because I think the session might have already got overwhelming. So for the time being, I think we used the filter function. We will use the select function the next time. And I think it's time to just conclude the session. And if there are any questions, you can ask in the comments, or there, how do we type or? Yeah. So the simple question is, how do we type or? So let me answer this. Type, you do not need, when you're saying or, you just need this symbol between two of your conditions, which is, I don't know what to call it, but this is the symbol. Let me just type it in isolation as well. And this is the symbol. So what, let me explain it over here is, so what it's saying is country is equal to Pakistan or country is equal to India, right? And then from the gapminder, filter to those rows where country is equal to Pakistan or country is equal to India. Okay, so that is one thing. This is India or Pakistan, exactly. This is India or Pakistan. Okay, yeah. So the pipe symbol, I think we will explain it the next time, because I'm assuming, because though the fact that I'm enjoying the session very much, many people are finding it, might be finding it quite overwhelming. So it is a good time to call this session off, unless Hassan have anything to say or ask.
Yeah. Dr. Aamir, is there any take-home assignment for the students?
Okay.
Or
Yeah. Before I get to that, I think there is another question Salima is asking. Can you find out the list of all packages and description somewhere? Exactly. That's a very good question. Let me actually very quickly show you the link for that, and that is our very quickly. There is a very good link from Just bear with me for a few seconds. I'm going to just Google that and just project the same page. Yeah, I got it. Let me share my screen. Let me remove the previous one, and then okay. Just bear with me because sharing the second screen is going to take a few seconds. Okay, so hopefully you're able to see a new screen. Actually, just a minute. Let me, because yeah, I hope so. This is the list, and it is by function, and it's a huge list of packages. This is where you will, and as I told you, there are approximately more than 14,000 packages, and you can like go through them. And let's assume like this is we go to one of them as an example. You can go to that, and you can also retrieve the PDF of the individual packages where all the details are very much listed. And the good thing is all this information is open source. You never have to pay anything to anyone for this. So yeah, this is it, and I will share the description of this. I will share the link of this in the description and as well as in the WhatsApp group. Thanks for asking that question. And okay, so okay, and then with that, so the question from Hassan was, do we have any assignment? I'm quite aware of the fact that this may be overwhelming for many of you. The idea is that you see this video and you see this again. And what I'm going to do is I'm going to put this description in the group as well. I'm going to arrange this video in the form of time chunks and timestamps. So you will be able to navigate through different portions of this talk. And the assignment is that I will share this document in the form of a PDF in the WhatsApp group, and you have to go through this lecture and the code and practice that on your own and come up with questions where you have for the next session. That's one thing. The second thing is that you have to evaluate this first session. I will prefer that you do that evaluation on in the comments of this video, because that is where I read that the data becomes organized. And when you're evaluating that, you can write anything, but I need answers to 3 questions. What was something which went good for this session? Which was something which was not very good? And general suggestion to improve the future sessions. So those are the 3 questions which I want to get answered when I'm looking to the evaluation. And I think, okay, can you share the link in the WhatsApp group? Yes, exactly. I will share that link in the WhatsApp group as well. Thank you. Or I think there are a few more comments or questions. Hassan, do you want to say something?
Yes, Dr. Aamir, I just wanted to ask one question. What is the total number of sessions that you will be conducting? And will the sessions always be conducted at the same time on a weekly basis? So logistically, that would help the participants. Thank you.
Yeah. So the answer to your first question is, for the timing, I'm planning for 3 sessions, and I'm going to see how the experience goes, right? And then we can, from there, what ideally I would want to continue, but obviously that is dependent on the response. The second is the timing. Tentatively is at the same time, because as you know that I'm also a full-time student and I'm studying, and my time is very tough with the end of degree. But this is again, tentative time will be the same for the next 2 weekends, which is 9 p.m. Pakistan time. But if there is some change, I will communicate that too through the WhatsApp group. After that, in the long run, what I want to do is to organize more focused sessions. For example, maybe 1 or 2 session workshop on data visualization, focused on data visualization. We can have a total workshop on your Tidyverse, which I just introduced, and so on. So there are so many areas where we can, if you have the basic knowledge, we can build up on that, right? So going to a few more comments or questions which are there, and thank you very much for a very patient and extensive session. This was really helpful. Please possible share the data sets and relevant links for practice. So the data sets which I used right now, you will not need any other external resource to use these data sets. Those are already, first of all, the empty cars data set is in the base R, and the Gapminder data set is there when you load the Gapminder package. But in the future, if we are using some other data sets, I will definitely share them. And the notes will definitely be shared in the form of a PDF in the WhatsApp group. And the link will also be shared for this package in the WhatsApp group. Okay, thank you, Salima. Okay, and then what is it? Okay, very useful. Very useful. Let me see if there is any question. So there is no question, and we have almost near to the 2 hours mark. And I'm extremely thankful to those who have stayed with me till this long in this live session. I will request you people to keep doing that in the future sessions as well, because the interactivity of these sessions is something which is going to add a lot of value to these sessions. With that, I'm not going to hold you people more. Hassan, do you want to say something before we call it off?
Just one last question. You had discussed that there could be a way that we could have a group where people could actually publish. So if people are already being trained on R, can they be associated in some way to publication so that at the end of the day, this becomes the incentive for them to complete through the whole course?
So the objective of this session was not to give an introduction to R, but what you are saying, that is a bit beyond the scope of it. But we can discuss this point later. You can put a message in the WhatsApp group, and we can take it from there for this point. Specifically, we can see what we can do for there. Okay.
Thank you.
Okay, and there are a couple of. Let me see if there is any comment or questions there. Okay, thank you. Thanks to all of those who have been with me and still writing the comments. I'm assuming that it's not very easy to listen to R programming for the new learners for this long. The good thing was that things were very simple, and bad things, we cannot do the same things simultaneously because we missed the next step. I can replicate these steps by myself. That's exactly what the idea. You get sensitized to the concepts in the sessions, in the live sessions, and then you have to revisit the same talk, because with the same link, the recording will be available. And what I'm going to do is I'm going to organize this talk with the help of different timestamps. So the way it happens that when it get organized with the help of those timestamps, you will be able to navigate to and fro in different portions of the video. And then what I will suggest that you do all of this on your own, right? You will have 2 resources available for that. One is this video, which will be organized in timestamps, and second is that the PDF document. Using that, you have to revisit these resources and do it all on your own and come up with questions in the later sessions. And thanks a lot for giving us your feedback. And with that, I'm going to call this video off and call it a day. Thanks once again to all of those who attended the session, and I will also be thankful to those who will be viewing the recording of this session. Take care for the time being. Allah Hafiz and bye. Other details. So we are here once again in front of everyone in continuation to our session on R programming, and as I announced in the WhatsApp group as well, that this will be a shorter session. This is going to be a 1-hour session. We are going to be talking a huge list of packages. And what is a package? A package is a bundle. A package bundles together code, data, or documentation and tests, and is easy to share with others. And there are more than 14,000 packages which R has. So this was a few things we'll repeat from the previous discussion. We were talking about the Tidyverse package, and we were discussing some of the verbs or some of the functions from the Tidyverse package. And as a reminder, whenever you are loading a package, what you have to do is to first of all install the package, and you will have to install the package with the help of this function, which is install.packages, and then inside. So I will remove the comment from this, and this, if I remove the comment from this code should work, which is that install.packages, and inside the brackets you will have this, the name of the package in the inverted commas. And because I have installed the package already, so I will not need to run this code, rather I will just be loading the package. And I will load the Tidyverse package, and the second package which I will need for this demonstration is the Gapminder package, which has the Gapminder data. And again, as a reminder, there will be quite a few things which will be reminder from the previous session, so that we can connect where we left and we can move forward ahead. So just as a reminder from the previous session, when we load the Gapminder data package, the data of Gapminder is already loaded, and whenever you are going to see a data frame, you can just use this head function to see the first 6 rows of that data set. You can also use this str function to see the structure of that data set. So what str will do is spell out the different variables and different details related to the individual variable, that what are the types of the variables and how many variables are there. In addition to that, there is another package which is glimpse package. We can not package, sorry. There is another function which is glimpse. You can also use that. I'm not going to do run that in the interest of time. And there is another way where you can use the view function to just see the data frame in the form of a spreadsheet. I'm also not going to discuss that because we talked about it in the last session. What I'm going to emphasize today's in today's session are 2 functions. One of the function is known as filter, and the second is one of them is filter, and the second is select. So these are the 2 verbs which we call it, is they're the part of the Tidyverse package, and we'll be discussing mainly about them before we go towards data visualization. And let me see, there are a few comments in. So there's a question straight away related to why head function gives you the first 6 rows. So as I told you previously as well, the head function is by default, like so whenever you have a function, there's a default setting of the function, right? So by default it will give you 6 rows. That is how it is programmed, right? But if you want to override for whatever reason, like you want to say to head, okay, give me first 10 rows, okay, then what you need to do is to add an argument of n equal to 10 inside this head function, and that will just return the 10 rows and so on. Like you can increase or decrease it by the number which you want. But your question is why it is giving you the first rows, because by default inside the coding, when you do not specify it, it means just n is equal to 6. That's how it is programmed. And thanks for asking that question. Okay, so now what I'm interested in talking about filter. What does filter does? It filters your data set and filters the rows of your data set on a particular condition, right? So what you can do here, what I'm doing, let me explain this code, what it is doing. So I'm interested in explaining filter, right? Okay, so let me write it down. So what I'm going to do, I'm going to take the Gapminder data set, and from the Gapminder data set, I'm taking the country column, and I'm just asking the question that for which rows country is equal to Pakistan. Okay, and so what does this code do? What this code is doing is it is taking the Gapminder data set and then asking the question within the Gapminder data set that where is the country column equal to Pakistan. Remember that when you are asking like whether a particular condition is true or is equal to like countries equal to Pakistan, you will have to use double equal to sign. And then, so this is all this code is doing. But if I do not assign it to anything, it will just run and it will print out what I'm seeing, right? Like it prints out all the rows which are for Pakistan, but that's not useful for me because I do not, I cannot use it later on. So what I'm going to do is to assign this to another data frame, right? And then use the assignment operator. So what I'm just going to get rid of the following code, which is just the repetition of what I just said, and I'm going to run it again. And again, like if I run the head function, it's going to do the same thing, print the first 6 rows of the newly formed data frame. Okay, so okay, please, if you can zoom your screen, let me try that, or let me get myself out of the way. And as at the same time, what is happening that most of the people are watching these lectures on mobile phone, which I think is also causing the problem. At this point in time, I'm finding it difficult to zoom into my screen. I hope that this will be enough. If it is not, just let me know in the comments. Okay, so I will move forward. Okay, and then in the same way, we can do other types of filtering. We can combine the information from 2 columns, as this piece of code is saying, that take the gapminder data and see where country is Pakistan and where year is greater than 1960, and save it to gapminder underscore Pakistan after 1960. And the same way, we can see the head of this data set. So it's something what we are using the same filter command, not a command. You're using the same filter function and using the same to limit the rows on 2 columns. And when I run it, I will get the rows where the data is from after 1960 and the data is for Pakistan. Okay. In the same way, we can also filter on the basis of 2 countries. So what this code is saying is that take the gapminder data set, see where the country is equal to Pakistan and where the country is equal to India. And again, I'm saving it to the data frame, which is Pakistan India, gapminder underscore Pakistan underscore India. And when I run this thing and run the head along with it, I'm going to see the data set which has the rows from Pakistan and India. Okay, so this is what the filter function is doing. Okay, now, okay, moving forward, I have so another thing which I want to emphasize in this lecture is something which we know as the pipe operator. Now, this thing is known as pipe operator. What is this? Okay, just let me write it down. And this is something is a new concept. I want you people to, I want everybody to understand it. And this is known as pipe. This is which is the percentage greater than sign and then percentage in combination. The 3 symbols in combination. We call it as the pipe operator. And what does the pipe operator does, right? It passes whatsoever is before the pipe operator to something which is after the pipe operator, right? So what I'm saying over here is take the gapminder data set and do something which is after the pipe operator to that gapminder data set. So right now what I'm saying is take the gapminder data set, pass it to this function, which is the filter function, and the filter function is checking for the condition if the life expectancy is less than 65. So what essentially I'm doing over here is taking the gapminder data set, checking whether the life expectancy is less than 65, and then saving this to another data frame with the life expectancy of less than gapminder life expectancy less than 65, and running it. Okay. I hope this pipe operator concept is clear. If it is not clear, I will request you people to clarify it over here, because it's a very important data manipulation concept that you will need to understand before moving forward with other data manipulation strategies. Okay, so I'm because there's no question at this point, but if you are not clear about this pipe operator, which is the percentage greater than percentage sign, please be sure to uh, understand this point, because this is a very important point. Okay, so moving forward in the same way, now I'm going to uh, move towards the second function in which I'm interested in explaining, and that is the till now we have been talking about the filter function, right? And the filter function was to restrict the data set on a particular condition and restrict the rows of the data set, right? But as you know that a data frame is a combination of rows and columns. Now select is going to restrict a data set on a set of columns, right? So what I'm going to do is, as you remember, that if I just for the sake of demonstration, if I print the head of Gapminder again, then this has many columns. Okay, this is country column, this is continent column, year column, life expectancy, population, GDP per capita, and population in million, right? So these are the many columns in the country in this data set. So what I'm interested in, for whatever reason, I'm not interested in every column of it, but I'm interested in restricting my data set to a few columns. Uh, uh, so I'm interested in restricting it to a few columns, because I just want to remove the mess. You'll in the real life you will encounter a lot of conditions where you will be having a lot of columns, and you will be interested in a subset of those columns. So if that is the condition, right, what I will do, I will use this select function, right? So what essentially I'm going to do is use this data set or data frame, I will call it, right? And then use the pipe operator. Now, what this pipe operator does is it forwards the data set, like it forwards the data set to any function which is after the pipe. And then I use the select function, and I put in the name of the columns which I want to select. For example, I'm interested in country. I'm interested in the column continent. I'm interested in year. I'm interested in life expectancy. I'm interested in these columns, right? So right now, this code is doing, and what this code is doing is taking the Gapminder data set and selecting the columns of country, continent, year, and life expectancy. And as again, if I run it, it will print out these columns for this from this data set, but it will not save it anywhere, right? But I also want it to be saved. So what I will do, I will just save it to another uh, uh, data frame with the name of Gapminder, or I will say Gapminder some columns, and then I will just run it. So now it has been saved into this new data frame, which is Gapminder some columns, and I will just uh, change with the new. I will see the head of the new we made data set data frame, and here it is. You have the first 6 rows from this uh, data frame with lesser number of columns. So there's another question. What is the the question is, what is the difference between pipe operator and simple filter options? So I think I was not able to completely and clearly explain what a pipe operator is. Uh, so filter is a function, and filter uses a particular condition. For example, we said that country is equal to Pakistan. It will check the rows for that condition, and then it will filter the rows on that condition and limit the rows on that condition, right? So filter is a function. Pipe operator is a generic I would call it you can call it a symbol or an operator or whatever you call it, just like an assignment operator, as we have this assignment operator. In the same way, pipe operator as assignment, what assignment operator does is it assigns everything to something which is on this side, right? It's just like an assignment operator does something like this. But what does the pipe operator does? It's pipe operator takes like whatever is on the left side of the pipe operator to the right side of the pipe operator, and allows you the programmer to do some function some manipulation on what is passed to to the right side. For example, here, what it is being said is Gapminder. And take the Gapminder's data set and then select these columns. And I can go on, like I can even pass it further. Whatever is resulted from here, I can just say, like rather than making it a separate line of code, I can just remove this line of code, right? And then what I can do is, with the help of this code, I can just straight away print it, right? So what I'm going to do is take this data frame, which is Gapminder, forward it with the help of this pipe operator. So whatever is there in this Gapminder data frame, forward it to the following function. And what is the following function? Select these columns from the Gapminder data set, right? Okay. So I've selected these columns, I've removed all of the columns, and then what I'm doing, I'm forwarding whatever result from the operation is, right? And then I'm finding out the head of whatever I was forwarding. And right now, normally within the head function, you will put in the name of the data frame. But here I haven't put in the name of the data frame, because that is already understood when you use the pipe operator. When I run it, it will just print out the same thing, right? So that is how the the pipe operator works. I hope it is clear. If it is still not clear, please ask me the question again in the comments. So there is another question. Salima is quite active here. And if we write filter Gapminder country is equal to Pakistan, how it is different from? Okay, so Gapminder. So first, there are two things which are there in your comment. First of all, when you are saying the first statement, which is Gapminder, comma country equal to inverted commas Pakistan, here you have to use two equal to signs, right? Because if you use a single equal to, that means that you are assigning country equal to Pakistan, which is not what we are intending to do right now, right? So that is the first mistake in your statement, but that perhaps was not the intention of your question. Your question was that how are these two codes different, right? So if you assume that the equal to sign is the same, there are two equal to signs in both of the statements, then both of them are equivalent. Both of them are equivalent in that case, right? Okay. Moving forward, and again, thanks a lot for asking so many questions, and you can keep on asking questions, because that's how I will also get an idea that are you able to understand me or not, or where am I able to teach properly or not, because virtual teaching is kind of challenging, because I'm not able to see a lot of things. Okay. In the same way, we can use the select operator in an opposite way as well, right? In the previous code, what I did, I explicitly wrote the names of the columns which I'm interested in, right? So I can reverse this in logic. And what I can do, for example, there are hundreds of columns. I'm interested in all of them, and I'm not interested in two of them, right? So what I can do, I can use the same code, but I can. So here what I'm doing, I'm taking the Gapminder data frame and then piping it, which means that I'm passing it to the subsequent function. And what is the subsequent function? Select. Remember, select is going to do. It is going to select a few columns, right? And then, so what I'm doing is, right now I'm using this negative sign over here, and with this negative sign, I'm using the negative sign population, and then negative sign in front of GDP per capita. So what this code is saying is, take Gapminder data set and pass it on to the select function, and within this select function, I have negative sign population and negative sign GDP per capita. So with this negative sign inside the select function, I want the function to remove these columns and keep everything else, right? So when I'm going to run it and then run the head of it, so you will see that all of the other columns are remaining in your data set or data frame, but just population and the GDP columns are removed. So this is another way of an inverse way of adopting your work, your data frame. Okay. So that was about the select function, and we use select and filter functions in R. If you are not clear about them, then please ask questions related to that, right? In the same way, we can also use another function which is known as arrange. Arrange is very simple. What it does is that it arranges your data set on the basis of a particular column. Right now, what I'm doing is taking the gap-minded data set, piping it to the whatsoever is in the after the pipe, and then arranging it on the basis of the life expectancy column, right? So what I'm going to do right now is so you can see when I print it out, it is just arranged in the ascending order in on the data frame is at arranged in ascending order on the life expectancy column, right? But if I want to arrange the same data set or in descending order on the basis of the life expectancy column, I just have to uh, enclose this life expectancy column with this DESC uh, function, right? So there is a small modification which I have to make, and then if I run this code, I will be able to arrange this data frame in descending order. And as you can see right now, the data frame has been arranged in a descending order. So this was something I think quite easy. Again, there are some other filter options which I've put in the code, and I think you can see more of these examples in your free time, because I've shared the code with the group in the WhatsApp. The last function which I want to talk about in the Tidyverse in the Tidyverse package is mutate. Mutate is something you want to manipulate the columns and you want to calculate a new column, right? So here what I'm doing is so I'm taking the gap-minded data set, using the pipe operator to pass it onwards to whatever is after the pipe operation, right? And then using the mutate function, and with the help of the mutate function, what I'm doing is I'm calculating this new column which is population in millions, right? And I hope I have the correct number of zeros. If not, then let me know in the comments. But you get the idea, right? So what I'm doing is I'm calculating the population in millions, and that is the result of a mathematical operation where you are dividing the population column by 1 million, and then you are assigning the resultant uh, data frame into the same data frame. So what will happen is that you will add a new column to your data frame. You can assign it to a different data frame. You can assign it to the same data frame, but like if you just want to avoid creating a mess and creating too many data frames, you can assign it back to the same data frame, and what will it will do? It will assign a new column to your data frame. I'm going to keep on looking for stuff if it is there. Let me see a few things. Okay. Right. Okay, so from here onwards, I'm going to talk about something which we know. There's another package, as I told you, that in R the functionality is limited to a number of packages, and the next package which I'm going to talk about, it is related to data visualization. It is known as ggplot2 package, and ggplot2 is actually, it stands for grammar of graphics, and the basic concept is that the basic concept of ggplot2 is that as you write any language, so visualization is also a language, and you can use different rules to make a grammar of visualization, right? So these rules will help you to make better graphics and to communicate your graphs in a better way to in different situations. Okay. One important point which you have to remember, and it's a generic point, but it is important to mention at this point, is whenever you are making visualizations, there are two self-explanatory objectives which are there for visualization. First of all, you may be exploring your data. For example, in the initial stages of your data analysis, you're doing exploration of your data and you're seeing what is happening in your data, what are different variables which may be correlated to each other, which may be related to each other. And you just want to get a feel of your data, as our teacher used to say. And and the next thing which you may be able to do is to explain the data, to communicate the data, right? These may be very quite similar but distinct concepts. For example, in exploration, you might not be very much interested in very much into like, okay, your graph should look good or things like that. But when you're explaining or communicating to others, then you would want your graphs to look pretty and presentable. So these are the two objectives. You need to be clear about the objectives of your data exploration, data visualization. Okay, now here is the important point, and before I move forward, I think okay, are we creating a new variable? So it is, I think, right. Okay, let me move back to the mutate. There's a question related to mutate over here. And okay, so what mutate is doing, and yeah, it is, as Salima, you rightly said, it's making a new variable in the same data set. So you can like use any type of mathematical operation. Like here, what I'm doing, I'm taking the population column, dividing it by 1 million, and I'm getting population in millions. So that, and you do that with the help of the mutate function. So what this line of code is doing is taking the gap pointed data set, using the pipe operator, passing it to this function, whatsoever is in the right side of the pipe. And what is on the right side of the pipe is this mutate operator. And within the mutate, you are giving the name of the new variable, which you name population underscore in underscore million. You can name in anything, whatever you want, and then you set it equal to the new mathematical equation, which is population divided by 1 million. I hope it is clear, and if it is not, once again, you can keep on asking questions. Okay, so now we're going to go into the ggplot2 discussion. Okay, so the concept of ggplot2 is that that whenever you want to visualize something, for example, if you want to make a graph on the piece of paper, how do you make it, right? You just like you make your graph in steps. You make your graph in step. You will if you have to make a graph on let's assume a scatter plot or a histogram on a piece of paper, how would you do? You would make an x-axis with the ruler, or y-axis with the ruler, and then there's a blank canvas. And then you keep on adding things, like you will add one line, you may add another layer, and so on, right? That's the basic logic of the ggplot2, that it keeps on incrementally adding the data to the canvas. So for this demonstration, what I'm going to do is use a data frame which is known as MPG. Right? This is the data frame which I'm using for this demonstration. And just as I told you, that whenever you have a new data frame, you can just see what the data frame is. And with the help of the head function, there are different columns. I might know or I might not know what these different columns mean. So what I can do, because this is a data frame which is inside our environment, so I have access to the details of this data frame from inside the R environment, which I think already opened. So let me just show it to you if I'm able to do that. So it's a fuel economy data from 1999 to 2008 for 38 popular models of cars. And these are the different names of the variables and their explanation. Right. Additionally, what I'm interested in doing, first of all, I want to draw a histogram for HWI variable, which is a quantitative variable. Right. And let me see what HWI stands for. stands for highway miles per gallon, right? So what I'm going to do is make a histogram, and you might know, and I think at this stage most of you will be familiar of the fact that histogram is used to visualize a quantitative variable. So what I'm going to do, I'm going to use this ggplot function inside the ggplot package. And the way it works is that first of all, I'm going to pass in the data set which I'm interested in, right? This is the name of the data set, MPG. And I'm going to use aesthetic argument inside this data set. And within the aesthetic, I'm going to pass in whatever is there on the x-axis. That's all for the time being, right? And I'm going to save it, this operation into this variable which is known as p, and let me run this code, right? So can you guess what will happen right now? Okay, so what I've done, let me print it out. Okay, see, this is an empty canvas which I was talking about, right? So in the first step, what has been made is an empty canvas, and this is exactly how you would do when you will be drawing something on a piece of paper, right? When you're drawing, when you're visualizing a data set, or you're making a graph on a piece of paper. So p, what does p contains right now is you have used the ggplot2 function and taken the data set and one of the variable from that data set, and you have put it in this aesthetic argument, and then I'm just printing this, and I'm assigning it to variable p, and I'm just printing it, and it will just print an empty canvas. So I can add on stuff on top of that, right? So on top of this empty canvas, I'm just adding geom underscore histogram, which will just add a histogram for the variable which I've already specified from the data set which I've chosen, right? And I'm saving the same variable again to its own self, which means that it is updated itself, and I'm going to print the new variable, the updated variable. So right now you can see what has happened is that we have a histogram on top of the empty canvas, right? But what is happening right now, there is no pretty x-axis variable, there is no pretty y-axis variable, and there is no title, right? So what I'm going to do is to take care of all these things. And since till now what is happening is that the variable p has this histogram saved to it, right? So that is there, but I want the x-axis labels and the y-axis label and the title as well. So what I can do is to take the variable p, add the x label to it. The function is x label, and within the brackets you will have to specify that whatever you want to put on the x-axis label. I'm putting the name of the variable on the x-axis variable label, and I'm using the y label function, or I don't know like whether you call it function or not. You just need to add y label to this, right? And then add count on the y-axis, and finally use this gg title to add the title to your graph. And when you add everything and just print it out, you'll have x-axis labels, you'll have y-axis label, and you'll have a title. But still I'm not satisfied because my graph is not very pretty, right? So I'm going to do something very simple but very important, right? What I'm going to do, I'm going to use another package which is known as a plotly package. I can install it with the help of this small code, but I'm not going to install because I've already installed. I'm just going to load it with the help of the library. And this plotly has a very simple function. It has the function which is known as ggplotly. And what you do, like your final plot, which was there, right? This is almost final, but I'm not satisfied with the looks of it. So I want to improve it. So the final plot is assigned to this plot object, which is known as, or variable, which is known as p. So I'm going to take this P, just put it inside the function of ggplotly, and I'm going to run it. And it's automatically going to print something for me, which I'm going to like very much. And I'm assuming that you will also like it as well. Okay. And with this simple manipulation, what is happening is that, let me, I hope it loads. Yeah. Okay. Okay. Just a minute. Yeah, let me do something to reset it. Okay. So right now what is happening is, look at this graph and look at it, like it is much prettier with one additional line of code. You have just converted into you've just got a very pretty graph. So this is a basic histogram. Okay. Selena has a question. I will just, in the interest of time, I will come to that question in the end. We'll continue with this discussion. If you have any questions related to these graphics, please let me know. Right. Okay. In the same way, now I want to move forward. What I can do over here, now this code is just a repetition of what I did, but it's doing everything in the same line. And let me explain it again. Like you can do all of it together, right? So what this is doing, this is the first line in which I used the HWY variable and assigned it to the dataset, took the dataset MPG and used the HWY variable and assigned it to like made an empty canvas out of it with the help of the ggplot object, right? And then I've added the geom underscore histogram to it, right, from this portion of the code, right? Then I've added the x-axis label, the y-axis label, and the gg title. And finally, I've saved everything to this variable, which is known as p, and I've printed out a ggplotly object, which is an interactive histogram. And when I run everything in this, I can do it all together as well, and you will get the same graph. Okay. When you use ggplotly, it will take a few more seconds as compared to your the simple graph, but the overall graph will be much prettier. Okay. Now, what I'm going to do is I'm going to have another qualitative variable. Rather than going through this code, let me do something else. Let's use the I'm going to draw a graph like this, right? But rather than using it through the MPG dataset, let's use the gapminder dataset, which we already had, right? And we have this dataset which we already used. This is the head of that dataset. Let me draw the histogram for life expectancy. Let me see how it looks like. It may take a few more seconds because this may be a larger dataset. So bear with me as the histogram for the gapminder dataset life expectancy loads. Now this is the dataset. Now this is the histogram with nicely labeled x and y axes and the titles, as I explained. What I'm interested in seeing how the distribution of different continents vary. And before I move forward, I think there is a question related to, please show the code of making histogram again, the first step, and explain the code. What does MPG stand for? Okay. Okay, let me go to that section of the code. Okay. As I explained that when you're making a plot with ggplot2, you're just making it incrementally. For example, this portion of the code, you are using the ggplot function from the ggplot2 package, and MPG is nothing but your data set, and HWY is the variable in the data set. So these are the two things. You can take this code and just modify these two things in your data set, like in your code, which means that you will have to use your own data set and specify the variable in which you are interested in. And what this piece of code will do is make an empty canvas, and when I print it out, it's not showing me anything, right? But when I add the geom underscore histogram to this p variable and assign it to the same p variable and print it out, it is going to print out a histogram for me. But now what is happening, the histogram does not have x and y variable. So what I can do with the saved p variable, I'm going to add the xx, x label, y label, and the gg title as well. So I'm going to add the x label, y label, and the title, and just print it out. Okay. So, and as I told you that with a very simple step, you can convert this non-interactive R graph into a very better looking interactive graph. And let me show when it prints out. You can see, you can hover over it and you can see the counts and different things, and you can zoom into any portion of it, and there are a lot of functionalities which you can explore in this graph. You can see things over here. Okay, so if you hover over it, there are zoom and there are box select and things like that. You can zoom in, zoom out, and there are many other functionalities which you can explore on your free time. And our so MPG, your question is, what is MPG? MPG was the name of the data set, and what I was interested in is move towards the gap-minded data set to make a graph like this. And this is the head of the gap-minded data set. Okay, and now what I'm going to do here with this piece of code is, as I told you, that you can do whatever I told you in a single line of code, right? Right now, what is happening over here is I'm using the ggplot function and taking the gap-minded data set, and I want to find out the histogram. I want to make the histogram for life expectancy, right? And so what this piece of code is doing, let me select the piece of code. This piece of code is doing is select the gap-minded data set and select the relevant variable, which is the life expectancy, and make an empty canvas, not a histogram. And then the subsequent portion of the code is adding a histogram on top of that canvas, right? And then, like, I can keep on adding things, right? The next portion, what I'm doing, I'm adding the X label, I'm adding the Y label, I'm adding the title. That is the whole, and then finally I'm saving everything. ggplotly function to convert the P, which is a non-interactive graph, into an interactive graph. And let me run it over here. It will show, as I told you, that it takes a few seconds to load because the interactive graphics take a few more time. Now you can see it's a very pretty looking graph, right? I can do one thing more. Another thing is, I'm interested in the distribution of the life expectancy by continent, right? So what I can do that is very simple. Rather than first of all before going that, I can do a few more things. If I'm not satisfied with the way that plot works, is I can like, let's assume that I just want to make the fill of the graph white and the outline as black. What I have to do to make a graph like this, within this geom underscore histogram, you have to put in color is equal to black and fill is equal to white. With this simple manipulation of the previous code, you'll be able to make a graph which looks like this, and you can choose any color which you want for the fill and any color which you want for the outline. The next line, what I'm doing, what I'm interested in is, for whatever reason, I'm interested in making a vertical line on the x-axis, right? So a line I want to draw which should be vertical to x-axis for some communication or demonstration purposes. So what I'm doing right now is taking the same P which I've saved to this plot, the code. This P has the plot of the histogram. What I'm doing is adding to that geom underscore vertical line, which is V line, and within that I'm specifying the details of the x-axis, right? And I'm specifying the color of this line to be blue and the line time to be dashed and size is equal to 1. And I just print it out. I added to the previous graph and just print it out, right? And see what happens. And see, there's a beautiful vertical line to the point which I specified, which is the 50, the point on x-axis, which is 50, right? And let's assume that I wanted to I do not want to hard code the number 50, but what I am interested in is to make this line at a point where there is mean life expectancy. How I can do that? I can also do that with the same function, with the same code, but here I just change the x-intercept is equal to mean life expectancy. So it will automatically calculate the mean life expectancy and it will automatically draw the v line to the mean life expectancy and just print it out. I'm moving a bit fast on this session because there's lesser time and a lot of topics are needed to be covered, but I hope I'm able to communicate what I want to. If not, you can ask me the question. But if you can see that the mean life expectancy in this data set is a bit lesser than 60 and a dash line is calculated at that point. Okay, so what else am I interested in? What I'm interested in the same histogram, just want to find out, I want to get an overall histogram as well, and at the same time I'm interested in making a histogram where the fill inside the histogram is equal to, like, gives me information about the continent. So after x is equal to life expectancy, I'm going to put in fill is equal to continent only, which is continent is another variable, right? And then I just print it out with this small modification. Let's see how informative our graphs get. Let's wait for it. See, like, you can see how there you can see the overall distribution of the variable, and you can see how the individual variables are distributed. And because this is an interactive graph, you can hover over individual points and find out what is going on, right? And what now I'm interested in is, okay, this, for me, I assume that this is this may be not very clear, this may be confusing, that what's going on. I want to draw histograms for all the continents separately, and I just want to do that with a single line of code. So for the previous line of code, what I do, I just add one more argument or one more line of code, which is I just add this facet underscore wrap and put in the name of the variable on which I want to make the histograms, and use this tilde and name of the variable, then and give the number of columns is equal to, which I'm going to explain in a minute what that will do. And let's run this function. Okay. So what it is going to do is, now you can see that because we specified the fill equal to continent, the color of the histogram is also specified by the continent. That's one thing. But what is happening, that for each continent you have different histograms, right? So with this facet underscore wrap, what you have done is you have made different histograms for at the level of the continent, and you have specified the number of columns equal to 2. So what I'm going to do over here is to this gives me a very different type of view. And if you want to, like, compare the performance on different qualitative variable or categorical variable, you can do that. Okay. So if you're not clear on this, I understand that this may be intimidating, but I would emphasize that you go over it again, and if it's not clear, just ask question and try it on your own time. It's It is not as difficult as it sounds like. Now the next, what I'm going to do, I'm going to do something very interesting. Let's assume somebody says, okay, I'm not understanding anything, right? I'm not able to understand what you're saying and what you're doing and how would I do it, right? I'm just going to make the job very easy for you. If you are a person who says that, okay, I do not understand anything, I'm going to make a function and you do not need to understand this function. I'm just going to run it. You just need to understand that you will have to run this once, this piece of code. When you're adopting what I'm doing, what I'm telling you, what next you have to do, right? Okay, so the next piece, let's say some of you says that, okay, this is quite difficult for me. I cannot follow, I was not able to follow it for the timing. What you can do is use these 3 lines of code and just understand them. And you will be able to understand and you will be able to make uh, a similar histogram if you run the previous line function, like the previous code chunk function, this one, and then run this line of code. So let me explain what these 3 lines are doing, right? The first line is assigning the data set to the variable data. The second is what it is doing. It is, let me actually run this, type the second one so that I'm able to explain it properly. So what it is doing, it's taking the gap minder data set with the help of, right, when I put in dollar, like I type in the gap name of the data frame and then type the word dollar, then it will open a drop down menu which will specify the number of columns in there, and I choose the life expectancy column. So what this line is doing is taking the gap minded data set and selecting the life expectancy column from it, and what I wanted to do is to assign it to the variable x, and that's it. That's all I want to do, right? So I run these 2 lines of codes, and then I just use this function which I just made, draw a histogram, and just give, you just need to run it. You don't need to do anything else. And it will automatically draw the complicated, it will just, not the complicated, but multi-line code, which we saw over here, that is just embedded in this 1 line of code, right? Whenever you want to use the same code again, you have to specify, you have to change the name of the data frame and then the name of the variable on which you want to, for which you want to make the data, the histogram, and you just need to run it like that, and you will get a similar interactive histogram. So that is a simple, you can call it as a function I've made for those who might think that this is quite intimidating and I'm finding it difficult to forward, follow, and those I've made this function. Okay, what is the number of column is equal to 2 here? Okay, so I got what you mean, and let me move forward over here. Okay. So as you can see, your question, Salima, refers to this plot, and let's see. So your question is, what is this number of column equal to 2 refers to? So let's see. I put in number of columns is equal to 1, right? Right now, the way it was run previously, see, there are 2 columns. All of your histograms have been ran in the first column and then in the second column, right? So let's see if I put in the number of columns is equal to 1. And rather than explaining it, if I'm able to show you visually, then you will have a better idea what does it mean. Again, it is going to take a few seconds. Okay, so you can see that now all the histograms have been arranged in 1 single column, and this look is not very pretty. So I mean, that is stretched out, the graph doesn't look pretty. So that is something which you will want to play around with it. So rather than that, I'm going to move it here and just like type number of columns is equal to 2, and all the graphs will get organized in number of columns is equal to in 2 columns. Okay, so right, so this is how it goes. I think we have hit the 1 hour mark over here, but I have to complete this session. Those of you who feel that they want to go, as I committed that I will be conducting a 1 hour session. Those of you who won't feel that okay, you want to go, you feel free to continue or feel free to go. I'm going to continue over here, and you can see it later on your own time from the recording of this session. Hassan, Dr. Hassan, do you want to stay or you want to go? What is your status?
Sir, I can stay for next 15 minutes. I guess.
Okay. I will complete the session, and if you want to go, just feel free to just log off, and later I can take on the session myself. I think there is not a lot of synchronized attendance because of Ramzan. I'm assuming, so that's how I have to actually complete what I have planned for today, so that because there is not a lot of time left in these sessions, right? Okay.
Sure.
Okay. So I will move forward. So this is the function which I told you about, and this is a single line of code. There are 3 lines, and it will essentially make the same histogram. Okay. So additionally, what I've done is that if you want your histogram to you want to use the same function, but you also want to add the X label, Y label, and title to it, you can also use this line of code and just modify your X label over here. Like you can modify this X label, this Y label, and this title on the basis of your need, and then you can run. And at the same time, as previously, this portion remains the same, which is the name of the data set, and the x-axis variable, this will remain the same. And if you run the whole of this code, it will have a very beautifully specified x-axis label, y-axis label, and the title for you. And again, it is going to take a few seconds, but with the help of this function, you can make this x-axis, y-axis, and title. Okay. So I'll move forward. Okay. Okay. So the next step is to the next thing which you want to do is to make a scatter plot. And again, I'm going to use this MPG dataset, and with the logic remains the same if you're making a scatter plot. Now, but this time, because a scatter plot is a plot which compares 2 variables, and one of the variable is on the x-axis and another variable is on y-axis. So first of all, with the same logic as is used by ggplot2, you will make an empty canvas, and you will use this ggplot function, and with that you will specify your data frame or the data set. Then within this aesthetic argument, you will specify what is on x-axis, which is DISPL on x-axis, and on y-axis you have highway, HWA, and just make it print it out. There will be an empty canvas, as I said, right? And what I can do is to, now this time, because I'm making a scatter plot which has points, the scatter plot, as you know, will have points, I will use this P and add geom point to it and assign it to the same variable P and then print it out. So now you'll have a scatter plot. And in the same way, as I said, and the rules apply in the same way to scatter plot as well. You can specify the x-axis label, you can specify the y-axis label, and you can specify the title with the help of this piece of code. And you have beautifully labeled scatter plot, but it is not interactive. In order to, we can do something else as well, because it's a scatter plot. You can add a linear regression line. And what you do with the previously specified scatter plot, as shown with all the labels and everything, you can add on top of that a geom underscore smooth with method equal to LM, which is a linear model, and then print it out. And here, what will happen that you will have a this line which is linear model, which is specified the linear model with the confidence interval specified by the standard errors on the basis of the relationship between displacement and high miles per gallon. Okay. And now I want to make this graph interactive. I will use the ggplotly function to make an interactive graph out of it. And as I told you that this is going to be a bit slower when it loads. It's going to take a few seconds. And see, now it is an interactive, and if you hover over any point, you will see, okay, or even the line, the standard error, you will see in the labels over there, right? So this is a very cool way to make a scatter plot. Okay. Now moving forward, whatever I did in the previous lines of codes, in the separate code chunks, I can do that all together over here in one line, and I will get the same code. I will get the same graph. Okay. Now I'm going to use the gapminder dataset, and let's see the head of the gapminder dataset, right? This is the head of the gapminder dataset, and what I'm going to do is to make a scatter plot between GDP and the life expectancy, where GDP is on x-axis and life expectancy is on y-axis. And I'm using the gapminder dataset for 2017 only, right? And I've made the x-axis and y-axis label over here, right? So let's make this graph, and let's see how it looks like. Okay, so this is now because this is the, let me just show you how it looks like. This is the scatter plot, and this is the scatter plot which we have right now. And what I'm interested in is coloring these individual points on the scatter plot with the help of the continent. So I can do that with the help. Before I do that, I'm going to use, I can make a smooth, I can use geom underscore. I can add the geom underscore smooth to the previous graph and see how is the regression line looking like in my graph. Okay. Okay. So here's the graph with the regression line. And then now what I'm interested in is that for each point, I want to find out whether to which continent does that point belongs, because each point is a country and want to find out to which continent that belongs. So with the very simple manipulation, as you can see, I've removed the geom underscore smooth because I'm not going to print out the line, the regression line for the points at this point in time. But what I'm interested in is that each point to which continent the individual line, the point belongs to. And I'm going to add another small argument, which is color is equal to continent, and the continent is the name of the continent. And I'm going to print it out. I'm going to run this code. Okay. So you can see now the dots have been colored on the basis of the names of the continents. The next thing which I'm interested in, because each of these dots are the countries, I want to make their size reflective of the population size. So I can do that as well. Or rather, before that, what I'm going to do is to add the regression line for the individual countries. You will see that how that look like for the individual continents. Sorry, and you can see each continent has its own regression line, right? Okay. Okay. So as I told you that what I'm interested in for each of these points, I want to find out I want to make the size of these points reflective of the population size. So for the previous code, what I can do is where I added color is equal to continent, I'm going to add another argument which is size is equal to population, this argument, and everything else remains the same. Right. I'm going to run this piece of code. And now in this graph, there is a lot of information. There is, oh, I'm sorry, I actually forgot to change the X and Y axis labels. That is the same from the previous graph, which you can change easily. So I apologize for that, but you get the idea. This graph is between the GDP and the life expectancy, and the color is shown by the color is showing the continent, and the size is showing the population of the country, and each dot is a country. So again, I've forgotten. Let me just correct it over here. And the X and Y axis label. The X label was the Y axis was. Let's see. And I'm going to modify the title as well. Okay. So now what I want to do is to make, as we did for the histogram, I can use the facet underscore wrap option to make separate histograms for each continent. Okay. And I'm going to run this piece of code and see what happens. See, like just as a histogram, we have scatter plots made for individual continents with their regression lines. So these are the types of manipulations which you can do easily for with the help of your ggplot2 library, and these are quite easy to do. So there is a question again. Salima is asking, please explain the code for scatter plot. Okay. So the code for scatter plot is over here. As I told you that you will be able to make it incrementally as you did it for your for the histogram. That's how ggplot works. So this portion is just making an empty canvas. Rather, let me explain a simple scatter plot first, okay, rather than talking about the complicated ones. So let's talk about this one. This is a simpler one. So what I'm doing over here is taking the MPG data set, which is here, putting it in the ggplot function, and specifying the x-axis equal to displacement variable, y-axis equal to highway variable, and then specifying the geom point will add on the points. The smooth geom underscore smooth will add the regression line, and then we have to put in the x-axis labels, y-axis labels, and the gg title. And then I save everything to this variable p and print out the scatter plot. Okay. And as I told you that it takes a few seconds to load because the interactive graphic is different. Okay, so this is your scatter plot. Okay, so let me move down where I was initially, where we were using facet underscore wrap to make a scatter plot like this, right? And what we did was that, so let me explain this piece of code once again as well. What I'm doing over here till is that I'm using the ggplot2 function and using this data frame gg gapminder underscore 2007, putting GDP on x-axis, life expectancy on y-axis, specifying the color is equal to continent, and then using the geom point to make a scatter plot, using geom underscore smooth to make a regression line, facet underscore wrap with columns is equal to number of columns equal to 2 to make a multiple scatter plots on the same graph, and then label it on x-axis, y-axis, and gg title, make a title of it, and then print it with the help of the ggplotly. When I run it, then you'll get a plot like this. Okay, moving forward. With this, in the subsequent code, what I'm doing is not very much. There's not a lot different, but I'm specifying and the standard error is equal to false. What that will do is remove the standard errors from these regression lines. So you will have the option to keep the standard errors or not keep the standard errors. And okay, so then right. And for the scatter plot as well, as I made for the histogram, I've made a function, and this is the portion which if you do not want to understand, you do not need to understand it at this stage. You just need to run this function. And this is for those who think that, okay, I'm not able to understand what you mean at this stage. Still, this is a portion of this talk can be adopted for you. What you need to do is to, first of all, after loading all the libraries which I've said, which I've mentioned previously, load this, run this function, and which is draw underscore scatter function. And what you need to do is to just give these things, as I specified previously, given the name of the data frame which you are which you are giving, like here, gapminder data set, save it to data. Within the gapminder data set, I'm putting GDP per capita on x-axis and life expectancy on y-axis. You can just choose whatever variable you want to put. And as I told you that, okay, like for you, first of all, you need to enter the name of the data frame, then the $sign, and then the name of the variable which you are putting in to x and y-axis respectively. Then you have to enter the name of the title, the label of the x-axis, label of the y-axis in the title, and then after you do that, you just need to run this code, and you will be able to make beautifully looking interactive ggplot2. So, with this line of code, which I think is much simpler and maybe easy to use, you can run it. I'm sorry for this. Let me just silence my mobile phone. Okay. So the last portion which I'm interested in is to make a line graph. Okay. So what I'm interested in making, I've loaded the gapminder data set for Pakistan only, where I've specified the country equal to Pakistan only, right? And with the help of the same code, what I'm trying to do is take the gapminder data set for Pakistan, which I just specified. I'm putting year on x-axis and GDP per capita on y-axis. And rather than geom underscore point, I'm specifying geom underscore line. And just like a scatter plot, the similar plot will be drawn, but this time it's a line graph. And let me load it. Okay, so now a line graph is made. And this time again, it's an interactive line graph. because if you hover on any point, you will be able to see, okay, which time and GDP it corresponds to. Okay, we have another data set which we made initially in the start of this demonstration, which was for India and Pakistan. I'm not going to go into details how we made it, but this is the head of that data set. I'm going to use the same data set to make a comparison between India and Pakistan. And what I'm going to do in this line of code is use this India-Pakistan data set for Gapminder, specify year in the x-axis and life expectancy in y-axis. And this time I'm adding another argument, which is color is equal to country. Now everything else remains the same as I specified in the previous. I'm going to run this piece of code. And so now we have a comparison for India and Pakistan in terms of life expectancy, and you can just make comments on these findings. So this is all which I had for the time being, as I ran quite a lot over time, because there is a lot of material to be covered. If you have more questions, please ask in the comments. And Salim is once again asking, what is method LM? Method is equal to LM and standard error is equal to false. Let me go to that portion of the code. So here, so this method is equal to LM is specifying in the geom underscore smooth, you're specifying method. When you say method is equal to LM, it means that linear model. You can specify other models as well, like you can use polynomials or other models, but right now we are using the linear model. And standard error is equal to false is that when you make it standard error is equal to true, which is, I think it is the default status, it will print the confidence interval as well. So let me do that. If I put true and now run it, that you can compare the two. Okay. Okay. As I told you that this is going to take a few seconds. It's taking longer than expected. Oh, let me adjust the screen like this. I'm sorry for this. Okay, so now you can see that you have the confidence intervals as specified with standard error. Now if I change the standard error is equal to false over here and run it again, the confidence intervals will be removed. So now you do not have any confidence intervals. So I hope I was able to answer the question. So can we add colors to the line, etc.? So yes, you can add colors to, I'm assuming you're talking about the line graph. If not, so just let me know. Yes, you can. If you're asking about like, okay, you can add other colors to this line. Yes, there are so many details related to this GG plot2 package that it is not possible to cover all of them in a very short session. As I have repeatedly reminded that these sessions are supposed to be giving you a broad overview, and I intend to conduct more sessions where I'll be focusing on different specific areas. But yes, you can do a lot of these things. You can add colors of your choosing. You can play with it in a number of different ways, which I will be teaching in my subsequent sessions. So with that, if there are not a lot of questions right now, I will call this session off. Thanks a lot for those who have been with me as live audience for this session, and thanks. I will also be thanking those who would be watching the recording of these sessions. If you have not subscribed to my YouTube channel as yet, I will request you people, everyone, to please subscribe to my YouTube channel and do not forget to press the bell icon. Please provide feedback for these sessions in the comments of this video, and take care for the time being. Bye and Allah Hafiz. This is going to be a very short session, and the objective of this specific session is to give you an idea on how to conduct different statistical tests using R. And before we go into conducting these tests in R, what we are going to do is going to revise and revisit a few basic concepts, which will be pretty much a repetition for most of you if you have taken some statistical courses, and it may be new for some of you if you have not taken statistical courses. So before going into R, I'm going to talk about different scenarios, and I'm going to talk about only two variables if you want to find out the relationship between two variables, and for the sake of simplicity, we're going to talk about some very common cases. So let's assume we have one variable and we have the second variable, and most common situation, it's always the case that either one of the variable is going to be a qualitative variable and the second variable is going to be a quantitative variable, right? So one of the variable will either be a qualitative variable or a quantitative variable, and same will be applied for the other variable as well. It means that for both of the variable, we can either classify each one of them into qualitative variable or the quantitative variable, and same for the other variable. So we can formulate this 2x2 table where we have one variable and the second variable on the top and the side, and for each variable we will find out whether that specific variable is a quantitative variable or that specific variable is a qualitative variable. So that is the ground on the basis, or that is the framework on the basis of which I'm going to explain some basic concepts. So if both of the variables are qualitative, then to make it very simple, without going into the further details related to assumptions, we will be most commonly we will be conducting chi-square test. So specific example of this condition is if you want to find out relationship between gender and smoking status. The first variable is gender, and it has obviously two levels. If we consider gender as a binary gender, and the second variable is smoking status, which can also be dichotomized into yes and no. So in this scenario, we'll be conducting chi-square test. Now, if there are two variables and we want to find out the relationship between two variables, and if both of them are quantitative, then we'll be finding out Pearson correlation coefficient between both of them. Again, the example of this situation is the relationship between height and weight, and we'll find out height being the quantitative variable and weight being the quantitative variable. So we'll find out Pearson correlation coefficient between height and weight if you want to find out the relationship between height and weight. As I said, that there are other ways to find out the relationship, but I'm just oversimplifying it just for the sake of this specific discussion. Now, the third scenario is that if one of the variable is a quantitative variable and another variable is a qualitative variable, and the qualitative variable has another characteristic to it, which is that there are two levels for the qualitative variable, then we will conduct independent samples t-test. For example, if you want to ask this question whether BMI differ across genders, then to find out whether the BMI is different across male or female, BMI is a quantitative variable, and gender, if we assume as male and female, then that is a qualitative variable, BMI being a quantitative variable, and we'll conduct independent samples t-test in this case. Moving forward, just a minute, I lost track of my screen, I'm sorry. Okay, so and the fourth situation in this 2x2 table is that if one of the variable is a quantitative variable and the second variable is a qualitative variable, but the levels or the number of levels of the qualitative variable are more than 2, which may be 3 or 4 or more than that, then we will use one-way ANOVA. And one specific example of this is, does height changes across MBBS classes, and height is a quantitative variable, MBBS classes Traditionally, we have 5 MB-based classes, so we will use one-way ANOVA. So this is some basic background. Before I wanted to go to our code, I just wanted to talk about this background. And now what I'm going to do is to talk about a few further details. And what specifically I want to do now is to share my screen again and show you how can we compute independent sample t-test and chi-square test with the help of R code. Just a minute, just give me a few seconds. It will take me a few seconds to share my screen again. It's giving me some problems, so I apologize for that. And let me just give me a few seconds so that I can. I'm going to unshare the PowerPoint window and going to share the R code. Okay, this is not good. Okay, what I'm going to do is to share my whole screen. Okay. So, and I hope that you are able to see my, okay, this is, let me actually try to share it again. I apologize for this inconvenience caused. I'm trying to share my screen again. Yeah, now this time it will work. Okay, I don't know where it was the problem, but now you should be able to see my screen where I have the R Studio opened. Okay, and the objective of this session is to help you understand how to conduct independent sample t-test and R, and to conduct chi-square test with the help of R. Now, before starting to walk you through this small piece of code, I have to acknowledge that I've adopted this code from this link. I'm going to put that into the description of this video as well. First thing first, you have to load all the related needed libraries. For this demonstration, I need Tidyverse and Plotly. These are the two libraries which I need. So this piece of code, what it's doing, it is loading Tidyverse and Plotly. The next, what I'm doing is I'm going to use this birth weight data set, which is from this mass library. So what this piece of code is doing is use this mass library, but just take the birth weight data set from this mass library, save that as a table, convert that as a table, and save it into the data frame which is known as birth weight. So I'm going to, if I'm going to run this code, so it's going to load it, and the subsequent portion of the code is, and what it's doing some data manipulation. If you are interested in that, you can go through that in your own free time, but it's not the focus of this specific discussion. What I'm interested is now, as I alluded to you in the previous session, that if you want to see the structure of a loaded data set, we can use the str function, and with the help of str function, we can see that this data set has 189 values and 10 variables. And there are a few variables in which I'm interested. For example, I'm interested in birth weight, which is a categorical variable, and birth weight, which is a continuous variable. So quantitative variable. These are the two variables which I'm interested in. And I'm also interested in smoking status. So what I'm interested in is, for this demonstration, is to check whether there is a relationship between smoking status and the birth weight or not. Right? Before going any further, I'm going to run some basic descriptives. And what I'm going to do is to take this birth weight data set, and from the birth weight data set, with this $sign, when you put the $sign in front of the data set, it's going to take out that variable. So I'm going to take out this mother spokes variable, and I'm when I put that in the brackets and run this code with the table function, it gives me the frequencies of how many individuals are having yes and how many individuals are having no as a response to this specific variable. And so this is just the first variable in which I'm interested in. The second variable which I'm interested in is birth weight in grams, and I do it in the same way. I take the birth weight, I use the dollar sign, and birth weight is the data set. I use the dollar sign, and with the help of this dollar sign, I'm going to extract the variable known as birth weight in grams. I'm going to use the summary function. What the summary function is going to do is going to compute all the parameters for me for a quantitative variable, which is the minimum, first quantile, median, mean, third quantile, and the maximum. So these are some things which I'm interested in, and summary function will do this all for me on its own. Now, what is happening? If you remember in the scenarios which I shown to you on the PowerPoint slides, is that we have a situation where we have one of the variable which is a quantitative variable, and the second variable is a qualitative variable, and the qualitative variable has two levels, which is yes and no, right? So we are going to use independent sample t-test in this situation. Before running an independent sample t-test, what I am going to do is to plot this and see how birth weight in grams varies across genders. So what I'm going to do, I'm going to use the ggplot function, and I'm going to take the birth weight data set and put mother smoking status on x-axis and birth weight in grams on y-axis. And I'm going to draw a box plot. And I'm going to put a nice X label and a Y label and a graph chart. And I'm going to save the whole of this code or the whole of this graph into this variable P, right? It's not going to do anything because I've not printed it. So with the help of ggplotly function, which I've explained in the previous session, is I'm going to print out or run this, and it's going to take a while, and it's going to make an interactive box plot for me where mother smoking status is on x-axis and birth weight is on y-axis. And you can see that there seems to be some difference in it between those who smoke and those who do not smoke in terms of the birth weight. But if we want to see whether this difference is statistically significant or not, we have to run independent sample t-test. Here I have to emphasize that I'm just going towards independent sample t-test without checking any assumptions. Ideally, in the real world, I will check some assumptions, whether the assumptions of the independent sample t-test are met or not. But because that is not the teaching independent sample t-test is not the objective. Rather, the objective of this session is just to teach to you how independent sample t-test can be run with the help of R. Therefore, I'm just jumping into that. And even before going into that, what I'm going to do is compute the mean birth weight and standard deviation of birth weight at the levels of those who smoke and those who do not smoke. So the way it can be done, what I'm going to do is I'm going to take this birth weight data set, I'm going to pipe it, which means that I'm going to forward it to this group by function. And what group by does is groups by the mother smoking status. And then whatever comes out from that, I'm going to pipe it, and I'm going to ask to give me a summarize with the help of this summarize function. Within the summarize function, I can specify what do I need as an output of the summarize function. And as an output, I need for each levels how many observations are there. So for that, you can use n and this two bracket signs. Then with the help of the mean function, you can find out the mean birth weight in grams at the level of mothers who smoke and who do not smoke, and the standard deviation of mothers who smoke and who do not smoke. So if I run this thing, the whole of this thing, what I get is a table which is showing me the number of observations, the mean birth weight, and the standard deviation of the birth weight at the level of those who smoke and those who do not smoke. And there are a few comments, a number of, let me see. Okay, so the question over here is, how do we test assumptions in R? Yeah, yes, we can test assumptions in R. For example, obviously, like a simple, straightforward answer to this question is that you always use Google. I use Google. Once you just like get familiar to our interface, you just like Google, okay, how do you check normality in R, whatever the other assumptions are, because that's not our topic, so we are not going to go into those details. That okay, but you simply Google and you will get a code, and then you use that. So that is a very simple answer to that. Since running the assumptions or the details related to independent sample t-test is not our topic. So unfortunately I'm not covering it. Maybe in the later sessions where I will be covering, I will focusing uh, in my parallel series in which I'm recording the videos rather than producing them as a live stream. I may cover this thing in detail, where I'll produce separate videos on t-test, separate video on chi-square test, and separate videos on individual tests. There maybe I answered this question, but right now I think that's not the scope of this specific talk. Okay, so moving forward from this table, now running t-test is very simple in R. Okay, what you need to do is, okay, so this, what I'm going to do, like R has a function which is known as t.test. This is the function which you are going to use, and this function has a few arguments. And the first argument is your quantitative variable, and the second argument after this tilde is your qualitative variable. So the quantitative variable is birth weight in grams, and the qualitative variable is mother smokes. And then after, so you are going to use it in this way, like the quantitative variable tilde the qualitative variable, and then you are going to say data equal to whatever the name of the data set is, right? I can run it directly, but I can here what I've done, I've saved it to another variable. The output has been saved to this variable, which is known as t_test. So I have to run it again to print it out, and it's going to give you this whole of the output. You can read it from here as well, there's no problem in it, but I would encourage you to understand the structure of this variable, which is known as t_test, because that's going to be very important for you. For example, if you go a bit advanced in or a bit forward, what you will want to do is to for example, I would want to like isolate only this t-test statistic, or I will be interested in isolating only this p-value. And what I mean by isolating is that, okay, I can just, one way of doing that is that, I can just copy it and just paste it here. Okay, that's one way to do it, but that's not what you want to do. What you would be interested in doing is that with the help of your code, you should be able to just print out the p-value or the test statistics or the confidence interval or the level of confidence or the other parameters which are there in the whole of this output. Now there are number of reasons to do that. I'm again not going to explain all the reasons why that is important. That will also be explained in one of my subsequent videos, but that is something which you would be interested in doing. So first of all, what I can do is, with the help of this names function, I can understand what is contained in this, because you can understand this t-test variable as a bag. This bag is, the structure of this bag is a list, and it has a number of components in it which you can separate. So one way to see, okay, I want something to tell me, okay, open the bag and see what is contained inside it. So I'm going to use the names function and put this variable t_test as the argument. It's going to tell me, okay, it has statistic, which is the test statistic. It's a parameter, p-value, and a number of other things, which means that I can extract these things from this t_test variable. What I'm going to do is that I'm also interested in knowing what is the type of this variable, because that becomes important at times. To know the type of the variable, as you can do some types of manipulation or some data structures and not other manipulations on other data structures. So if I write type of this t_test, and it comes out to be list. Okay, so okay, as I said that, and I'm going to go again into the if you see, like this t_test variable that has the whole of the this output, and I am now interested, first of all, let's go step by step. If I am interested in extracting only test statistic from this, right, how am I going to do that? And the reason I'm going to need that is, at times you are going to, this document which I'm working in, that is known as R markdown. So what you are going to do at times is, if you're writing a paper, what you would want to do is to refer or use that specific variable in your writing. so that it automatically updates rather than you manually updating it. Let me explain that in a bit. But so what I'm going to do over here is that this t underscore test is a list, and I'm going to use this $sign, and with the help of this $sign, so let me demonstrate it over here in parallel. So if I type t underscore test and I enter $sign, then it's going to open a drop down menu for me, which if you can compare with the output of the names, these are exactly the same, right? So you can approach or you can access these things with the help of this $sign. So if I print this specific line, what you can see, it's printing only the t test statistic only for me, right? So that's exactly what I've done over here, is that I've extracted the test statistic, I've saved it to another variable of t statistic, and then I've printed that. So if I run the whole of this code, the same is going to be the printout of it. And now what I'm interested in, why I do that, right? Let me explain that in a bit, because this is going to be quite interesting and a very important strength for R. Is that if I'm converting this into a report or a paper, what I'm going to do is that we found that the t statistic was, so one way is to like, okay, I will do this thing, I will just copy and I will paste it over here, right? Okay, this is also something which will work, right? But this is not recommended in R, because let's assume something changes, your variable changes, your sample size changes, your sampling strategy changes, right? What you are going to do, what you are going to do is you have to manually change it again. So a better way to do this, I extracted this variable. What I'm going to do, I'm going to copy this variable and I'm going to use this. There's if you see on your keyboard, there is some below the escape key, there is something which is a tilde, and if you press shift and press tilde, after pressing shift and tilde, sorry, not below the escape key, there is a key which has tilde on it, and if you press that key without pressing shift and then press R, okay, then write this variable inside this code. Like, so when you knit this thing, it is going to show this number right now. Now, if you could not understand this part, that's completely okay. That was kind of an aside from this specific discussion. But at this point, what you need to know that you will at times need to extract these variables from the complex output of the t-test statistic, because you can let your text to be automatically updated. Okay, let me go there because I think there was some other question. So what is type of for? So let me go back over there. So whatever variable you have, right? If you're not sure what is that, one way to see is you have this function which is known as type of, and you find out the type of that variable, and it will give you numeric, it will give you character, it will give you list, it will give you double. And we kind of walked through these data structures in a hurry in our first session. And but if you know, okay, something is a list, something is a character, you can do some things with that, not the other things with that. So type of will tell you, okay, what is the type of this variable. That's what the function type of is doing. Going forward, now the next thing which I'm interested in is extracting the p-value from this variable, which is test statistic. What I'm exactly doing, I'm going to do that. The exact same thing is to type that variable and to press the $sign and then like extract the p-value. And if you see the p-value will be there, that is the exact thing what I've done. But I've saved it to p-value and just like printed it out again. In the same way, I can print out the confidence interval, extract it, and now you can see that confidence interval in itself is in itself has many things, right? And if you want to extract the lower limit of the confidence interval, then you can use these two brackets parenthesis, and then like the first lower confidence interval will be printed. And if you use so if you put 1 in these brackets, the lower confidence interval will be printed like this, and if you put 2 into them, then the upper confidence interval will be printed. And you can also, what you can do is save them into 2 other values. I will say CI lower, and I can call it CI underscore upper. Right? I can print it like that, and when I print this variable, it's going to print out the lower confidence interval. And in the same way, if I print the other variable, which is the CI underscore upper, it's going to print out the upper level of the confidence interval. That is how you can extract the individual components from your from the output of in the t-test. So I hope this was a bit clear. If it's not clear, you can ask questions, or if you're watching it live, you can ask question live, and if you are watching its recording, you can type the question in the comments, and I can answer them later in subsequent videos as well. Okay, so with that, I'm going to move towards the second important demonstration related to this talk. As I told you that this is going to be a short talk, but it is quite important because this skills t-test or chi-square test, that are some of the most important statistical tests which we perform in our statistical analysis. So I kind of chose them. I chose not to talk about a lot of stuff, but a few things, because these are kind of a very new concepts, and I didn't want to bombard you with a lot of statistical concepts. So the next thing what I'm going to do is to find out, if you remember, let me go into the structure of the data set over here. And if you see, now I'm going to apply a chi-square test. So one of the variable which I'm going to use is whether mother smokes or not, right? And the second variable which I'm going to use is this categorical variable or the qualitative variable, which has 2 levels, right? And that is whether the birth weight is below or above 2500. So I'm going to check the relationship or association between these 2 variables using the chi-square test. And how am I going to do that? Let's move to the point where we were. And first of all, what I'm going to do is to do a simple cross tabulation, as you will do in SPSS. And what you do is you extract the first variable, which is the categorical variable for the birth weight. And the way you extract that variable is take the name of the data frame, use the $sign and name of the variable. That way you extract the first variable. You extract the second variable in the same way, and you put them, both of them, inside this function which is known as table, and it's going to print out a simple cross tabulation. I have to remind you that this cross tabulation is oversimplified. It doesn't have any kind of proportion. You can manipulate it to print out proportions as well, but that is not the intent at this point in time. It's just showing the numbers. Over here, what I'm going to do, I'm going to save this table, which is exactly the same code. I'm going to save this into another variable, which is a birth weight BW underscore table, which is, so I'm going to save this into this thing, right? Okay. And what I can do over here, I can take this table and use R as this function, which is known as chi-square test. So this is the name of the function, which is chi-sq.test. Okay, and I'm going to run it on the output of the first line, or that table which I printed out over here. I'm going to run this code, and let's see what happens. So it is printed out chi-square test output for me. And again, like the previous situation, it's again a combination of a number of things, and I'm not interested in this. I want to extract the chi-square test value, and I am interested in p-value and maybe other details of that. So what this next line of code is doing the exact same thing, but it's a kind of running it on this directly. So what I've done over here is just save into another variable and run the chi-square test of it. So this, you can ignore this line because it's doing the exact same thing. And here, so rather, what I'm doing over here is I'm going to save this thing, the output, into chi-square test, chi_test variable. And in the same way, I checked for the names where for the t-test, I'm going to check the names of this with the help of the names function. I'm going to check what is contained inside the chi-square test, and that will tell me that what is inside it. Okay, so as you can see, that has test statistic, that has parameter, p-value, method, and a number of other details. And in the same way, if I want to extract that test statistic, I can do that with the help of putting a $sign in front of that variable, which I just saved over here. And you can see that test statistics for chi-square test is this 4.23, 4.235 something, right? You can extract the p-value, and you can also extract other parameters from this output. So this was a very short demonstration, and it was intentionally short to keep us focused and to introduce this concept of how to run a chi-square test and t-test, independent samples t-test on R. And in the subsequent videos, we are going to extend on this concept. We're going to talk about a number of other tests which are ANOVA and a few of other tests, and we are going to move towards the linear regression and logistic regression. Those of you who have stayed online with me online, I'm thankful to you. Those of you who have stayed online through this live stream, I'm thankful to all of you. And those of you who would be watching this recording, you can give me your feedback or your questions in the comments. I will. Okay, I got confirmation somehow in the comment that I am able to, I'm audible. Therefore, in the interest of time, I'm going to jump directly into the session. And once again, first of all, I apologize for restarting these sessions late. It's been quite a while where I've not conducted these sessions, and I'm going to remind the viewers related to the format of this session. If you are watching this session live, you can ask me comments in the comment section, and I'm going to project that question of yours as like this on the screen, and I'm going to read that question, and I'm going to answer that question. So that is going to be one of the basics related to the interactivity of these sessions. But if you are not able to participate in the live session, that's also fine. You can ask me questions later on by writing a comment in the comment section of the recorded video. And the video will remain on the same link. Today, we are going to be talking about modeling with the help of R, and we're going to be starting this discussion with the help of linear regression. For those of you who have just joined, I will request you, if you are not able to understand a specific point, to please ask me a question in the comments. And the way to do that, I'm going to repeat that because a number of people have just joined, is that you have to write the question in the comments, and I'm going to respond to that. So in the interest of time, let's jump directly into this session. As I said, that the session is going to be talking, this is the last lecture in the series of sessions through which we are introducing R programming. And in these sessions, we have just gone very fast. We have talked about some basics related to R programming. We have talked about descriptive statistics related to R. We have talked about some statistical tests by using R. And today, through this very short session, we are going to introduce how to build model in R. These are not going to be an exhaustive content. I'm planning to, as this is going to be the last session in the series of sessions, which we have already started, I'm going to start another series very shortly, in a week or so, where we are going to be talking and taking each one of these topics in depth, and we'll be discussing these things in a lot of details. This is just a sensitizer to you so that you can get used to our environment and get exposed to different terminologies. Okay, now about the topic, we are going to be talking about usage of model in R, and we are going to be using linear regression as an example. And just a few announcements before we jump into the topic is that I'm assuming that people who are viewing this session to have substantial understanding of what linear regression is, because teaching linear regression is not going to be the objective of this session. Rather, the objective of this session is how to use R to formulate a linear regression model. So that is going to be clear. Therefore, I'm going to pass very quickly over the details, like the theoretical details related to linear regression, and I'm going to talk more about our code. So I'm going to move forward with this, and I'm going to move towards the content of this presentation. And as I told you that I'm going to be giving a very brief introduction to linear regression, introduction to the data sets which I will be using for this specific demonstration. I will demonstrate some basic statistics on the before going to the modeling. I'm going to talk about some basic descriptive statistics. Then I'm going to go into linear regression and its components. I'm also going to teach how to formulate regression diagnostic plots, and I'm going to teach you how to make your output prettier and with the help of some code. So this is going to be the outline of today's session. Okay, so there is one question. How many previous sessions? Because I joined today. Just quickly to answer this question is that we have had 3 sessions before this, and it's okay if you have joined today. I would recommend that you see this session till the end, and then if you go to my YouTube channel, there are all the recordings of all the previous sessions are there on the YouTube channel. So if you're interested, you can watch them all right from the beginning and then catch up later on this. But obviously up to you. That's what I would recommend. Okay, so talking about regression, what is regression first of all? Let me go to the next slide, and this is all we are going to be talking about, the theoretical details related to linear regression. When I talked about regression, I meant linear regression. So this is all of the theoretical details which I'll be talking about linear regression. I'm assuming that those who are attending this session will already have a substantial understanding of what linear regression is. So linear regression is a linear approach for modeling the relationship between the scalar response variable and or more of the explanatory variables. There are 2 types of linear regression. One is simple linear regression, in which there is one explanatory variable and one outcome variable. And there is multiple linear regression and more than one explanatory variable, and definitely obviously one response variable is there. Okay, so as I said, this is all of the theoretical details which I will be talking about today, and I'm going to, as I said, that the objective of this session is to walk you through the code which you can use to formulate a linear regression model. So I'm directly jumping into the code. So here is the code, and as you know that whenever we start coding in R, first of all, we load the important libraries which we'll be interested in. So these are the libraries which I will be interested in. So I'm going to load these libraries, and these are loaded. And then I'm going to go straight into this data set, which is known as, the name of the data set is Boston. And if I want to just see this data set, you know that there is a function in R which is known as head, and you put in the name of that data set as an argument in the function head, you will be able to see the first 6 rows of your data set, and the columns, all of the columns will appear, and if the columns are greater than the amount of space which is present on your screen, you can use this small arrow to see whatever other columns are there. And as you can see that there are 6 rows of 13 columns. But what I want to do, I want to understand the structure of the data in a better way. So there is another function which is known as str, and I use the str function and use the name of the data set as the argument inside the str function. And what this function is going to do is going to give me the details of individual variables in the data frame, meaning that what is the type of the variable, and give me a glance of whatever is inside the variables. It's also going to give me the number of observations which are there in the data set and the number of variables which are present in the data set. But here I do not know, because I just got exposed to this Boston data set. I do not know, okay, what is RAD, okay, what is CHAS. These are all acronyms or short names for the names of the variables, and I'm not sure what they do. So for those data sets which are with some of the R packages or are present in base R, what you can do is use a simple trick to find out what is there inside this data set, which is that you put in a question mark and write the name of the data set and then run this simple line of code. Now what is going to happen is that if you see on this side, something is going to appear. It's a link has appeared which is talking about the Boston data. Okay, and I'm going to click on this link, and you can see that it's saying that Boston data is the part of this ISLR2 package which we just loaded. Okay, so there is a comment which is saying that text on screen is not visible. Let me see what I can do for this. Okay, let me see. Okay, so I hope this makes it better. Next time I will try to make it a bit bigger. In the interest of time, I'm not going to mess up with the font size at this stage. Okay, I'm assuming that you're for those of you who cannot see the text on the screen, I will request you to use laptop to watch these sessions rather than using your mobile phone, because codes can be non-readable on the mobile phones. That's what I can say right now, but I will you will do some part, I will do some part to make these sessions more comprehensible in terms of the text size which are concerned. Okay, so this is the Boston data, and as I said that this is the part of ISLR2 package. And you can see, okay, you what we were talking about is some of the description of this data set, and we can see that the data set, and this data has a description which is that a data set containing housing values in 506 suburbs of Boston. Okay, and these are the details of variables. For example, we can see that CRIM is per capita crime rate by town, ZN is the proportion of residential land zone for lots over 25,000 square feet, and so on and so on. And you can see what each and every variable means, and we will be using this as our guideline whenever we are stuck in terms of the interpretation of these data sets, that which variable means what. And if you want to use it, there is a reference for this data set as well. You have to cite it, and there is an example code of where this data set has been used as well. So this gives you some overview about what the data is about. If there is any data which is part of any of the R package or it's part of the base R, you can just type question mark and the name of that data set, and you will hopefully get similar details for these data sets. So what we are going to do right now, we are going to directly jump into some descriptive statistics. And by descriptive statistics, we mean that, okay, all of you know that before we do not run into modeling straightforward. What we do is that mostly we draw some graphs, we run a few descriptive statistics. So right now what I'm interested in is I'm interested in finding out the variables which are able to predict the median value of owners occupied homes in $1,000, which is represented by this variable called MEDV. Okay, and I'm going to see the relationship of this MEDV variable with other variables. So first of all, I'm going to see how MEDV is predicted by LSTAT, which is the lower status of population in terms of percentages, and I'm going to draw a scatter plot. And a scatter plot can be drawn with one of this function, which is known as qplot function. And the way qplot function works is that you first of all put in the x-axis variable as an argument, then the y-axis variable, then you put given the data which you want to use for this scatter plot. This portion of the code will give you the scatter plot, but what I want to do is I want to label the x and y axis as well. So I'm giving an interpretable x-axis label, an interpretable y-axis label, and an interpretable title for this plot as well. And I'm going to run this code. Okay, and it's going to take a while. And if you can see that there is a negative relationship, there is a negative correlation between median value of owners occupied homes in 1000 and the lower status of the population percent. And we can use this relationship in a model and to find out how the linear regression will work out in this between these two variables, where we want to predict MEDV with the help of LSTAT variable. In the same way, just to demonstrate, oh no, I have not used any other scatter plot. So this was just to demonstrate one of the scatter plot. You can draw with the help of similarly, you can draw other scatter plots as well using other quantitative variables, or if you have qualitative variables, you can draw box plots for the levels of the quality or categorical variables to find out how the dependent variable varies across the levels of the qualitative variable. But that's what I've not done here. What I've done here is I've jumped directly into a linear regression model and how to formulate a linear regression model. And the linear regression model can be run with the help of this function, which is known as lm. And what it does is that, first of all, okay, what is your dependent variable? As we discussed, that MEDV, the variable name MEDV, which stands for median value of the owner occupied homes in 1000, that is going to be our dependent variable. And now at this stage, I just want to choose one of the variable, which is LSTAT. And the next argument is going to be data equal to whatever the name of the data is. And I'm just going to run this line of code. And what this is going to do is going to run a linear regression model where the dependent variable is MEDV, the independent variable is one variable, which is LSTAT, and the data is Boston. It's going to take MEDV and LSTAT from the Boston data frame and is going to run a linear regression model on it, and it's going to be saved to an object which is known as lmfit. I've named as lmfit. You can name it whatever you want, and I'm going to show this lmfit data, this object, and this is what it is showing. It's showing the formula which you used, and it is showing the intercept and the coefficient of the LSTAT. That's all that it is showing over here. So what I'm going to do right now, now this is kind of weird because when you just print out this lmfit variable or whatever to whatever variable you have saved your linear regression model to, it's going to give you a very simple output. But if I find out the summary, use the summary function and put in the name of the object of the linear regression model, I get a lot of more details, right? I'm going to talk about these details in a bit, but first of all, let's see what is actually contained in this object lm.fit, right? So I'm going to use a function which is known as attributes, and I'm going to take lm.fit as an argument. And okay, so these are the attributes, which means this lm.fit contains coefficients, it contains residuals, and is contain many of these things, which means that if I want to, what I want to do is, if I use this lm.fit object and use the dollar sign and choose the first component of this lm.fit object, I'm going to get the coefficients. Okay, in other words, if I'm just interested in coefficients from this object, I'm going to use this line of code, right? So I'm going to do something very simple, but it may sound weird, but you have to do it the way I'm saying you do, and it will become clear why I'm saying it in a bit. But what I'm going to do, I'm going to take the summary of lm.fit object, and I'm going to save it in another variable which is known as lm.fit_summary. You can again save it in you can name it whatever you want. I'm just naming it lm.fit_summary, right? Okay, and so what I'm going to do is I'm going to find out what are the elements which are contained within the object lm.fit_summary, and it will give me, if I run the function names names and with the argument as lm.fit_summary, these are the objects which are contained inside the these are the elements which are contained inside the object lm.fit_summary. Okay, so I'm going to what I'm going to do is that I'm going to I'm only interested in coefficients from this summary linear regression model object, and I'm going to just print that out and to show you how it looks like. Now you will see that, okay, there is a lot of important details which have been spelled out in which you're interested. For example, you will be interested in standard error, the t-test, and the p-value, and the absolute value of the coefficient, and the value of the intercept as well, right? At this stage, you can see that they have been not rounded off, which means that they have a number of decimal places. What I want to do is that I want to round it off to say 3 decimal places, and what I can do is I can take the whole of this code and put it inside the round function as one of the argument. The whole of this line has been put over here, and I'm going to the second argument is going to be the digit 3, which is, I'm telling the round function that, okay, take whatever is in the columns, the digits inside these columns, and round it off to 3 digits. Okay, so when I run this, I get a very beautifully rounded off, automatically rounded off output to 3 digits only. You can see this p-value values have been rounded off to 0, because you know that p-value can be, if you can see over here that they are very, the p-value is very low, and that have been rounded off to 0. And if you want, I will show you later on as well how, if you choose, you can choose not to round them off to, or you can choose, or you may not choose. It's up to you, whatever you want. But this is one of the options with the help of which you can round off the variables. So far, I am hoping that those of you who are online are understanding it. And as a reminder, if you are not able to understand, you can ask me questions by asking questions in the comment, and I will continue with the session. Okay, so we have made a linear regression model, and now we want to understand how good or bad that linear regression model is, right? So there are a few ways which we can do it, and I'm going to make a few plots. Okay, so what I'm going to do, I'm going to run this piece of code, and let me explain what I did. Is this first line of code, what I'm telling R, then okay, this part function is going to tell R that, okay, make these graphs in 2 rows. Okay, this is the first row and this is the second row, and and this plot is the function, and I'm going to use the lm.fit object which is originally used. Let me show it over here. So lm.fit is the object which was created after the linear regression model was originally run, right? I'm going to use this lm.fit object as an argument inside the plot function, and I'm going to run this code, and I'm going to get these 4 plots, which I'm going to use to interpret that how good or bad our linear regression model is. I will give you a few seconds to see this these graphs and figure out if you can find out. So these graphs are used to understand and to interpret how good or not good the assumptions related to the linear regression model are. And we are going to comment on each one of them very briefly. The first one of the graph is residual versus fitted when a linear model, regression model is formulated. This is one of the graph which we draw in order to interpret. And what this shows is that as you can see that on x-axis there are fitted values, and y-axis there are residuals. And what we want to see is that residuals will have a constant variance when plotted against the fitted values, which means that you can see that in here the variability is changing, but we will want to have the variability to be constant across these. And the residuals and fitted value will be uncorrelated. So we can see that they are not correlated, but there is some variance of the variance of the residual across the fitted values varies. So that is something which we can observe related to this graph. The second graph is a QQ plot, which is used to find out the how good whether the standardized residuals are normally distributed or not. Okay, and we can see that we can use a linear model for prediction if the underlying normality assumptions don't hold. However, in order for the p-values to be believable, the residuals from the regression must look approximately normally distributed. So you can see that they are not completely normally distributed. As you can see that they deviate from the normality over here. But yeah, I mean you can comment on the normality of the residuals with the help of this graph. Okay. The third graph is known as scale plot. And this is another version of the residual versus fitted. There should be no discernible trends in this graph. And the fourth graph is talking about leverage. Is showing the leverage versus residuals. And leverage is a measure of how much an observation is influenced, how much an observation has influenced the model. It's a one number summary of how different the model fit would be if the given observations were excluded compared to the fitted model where the observations are included. Points with high residuals and high leverage are outliers. They are skewing the model fit away from the rest of the data and don't really seem to fit with the rest of the data. So we are going to be observing where there is a outlier in the data or not, and just if you want to go into further details related to this point, I've put in the source of this text in here as a reference, and I will be sharing this code through our WhatsApp group as well, so you can go on later on as well and see it and explore it if you want to. I'm going to move further, and so far we have just used a simple linear regression model where there was one explanatory variable and there were one outcome variable. How if you want to do the same thing where there's obviously one outcome variable with a number of explanatory variables? The same concept is going to apply. If you understood what I taught till now, you can easily replicate this process with very small modification, and you can use a multiple linear regression model. And the way to do that is okay, so what we did is that now what we want to do is we want to predict this MEDV data set. sorry, this MEDV variable. And what I want to do is I want to use all the other variables in the data set, which means age, which means RM, NOx, DIS, etc., all the variables in this Boston data set to predict MEDV variable. And that is possible if, so I use the same code. If just let me show the code which I previously used. In fact, let me copy that and paste it just along with it so that you can see the difference and develop onto that on the basis of that, right? So this was the original code, and this the one which is selected right now. This was the code. Oh, I'm sorry, I just forgot to put it full screen. Okay, so what I was saying is that I've just copied the code from the previous part where I just use one dependent variable and one independent variable, and I'm just copied that portion of the code, and now I'm going to use the same code to make to adopt the same code to make predictive model, linear regression model, where the dependent variable is going to be MEDV, and I'm using all other variables in the data set to predict MEDV. And what I'm going to do initially, what I was using this tilde symbol, and then the name of the variable which I'm using to predict. But here, what I'm going to do is I'm going to use tilde and just a dot. This dot is going to tell that, okay, use all the data, all the variables inside the Boston data set except MEDV variable, and construct a linear regression model and save it to this object lm.fit_all. I hope this step is clear. If it is not clear, please stop me and ask questions by commenting in the comments. I'm going to run this and it will be saved in lm.fit_all. What I'm going to do, as I demonstrated previously, I'm going to take this lm.fit_all and save it into the summary. I find out the summary of this and save it into the summary object. And I'm going to run this code. And then finally, I'm going to take the coefficients from this summary object and round the coefficients to 3 decimal places. So what I've demonstrated previously, I've just done it quite quickly without a lot of explanation, because I've already explained that previously. And as you can see right now is that all of the variables have been included in our model, including LSTAT, which was previously included, and all other variables, their estimates, standard errors of the estimates for the coefficients are there. And then what you can see is that there's a t value over here, value of the t statistic for each coefficient is there, and the p-value is also there. Okay, so in the same way as we discussed, we can run the diagnostic plots for this model as well. The code is exactly the same. With object lm.fit_all, which was the which was this particular object, as which was formulated as a result of lm function being where MEDV was the dependent variable and all of the variables were the independent variables. And you can interpret these graphs on the basis of the instructions which were given previously. And finally, there's one last point before I end this session, is that if you want to, okay, this is also good, but if you want to improve the way your output is being shown on the screen over here, or like you want to show it like this, or you want to improve the way it is being shown in the document in which you save, or in the HTML file which you are going to knit as a result of this presentation, you can use this cable function, and you can put in the lm.fit_all_summary object and take out the coefficients from that. And this argument, which is digits with this vector 3344, which, and that is, these digits are telling the cable function that round the first, okay, this 3 is telling it to round the first column into 3 decimal places, the second into 3 decimal places, the third into 3 decimal places, and the fourth one into 4 decimal places. So with the help of this function, what you can do is that you can also control each that to which how many number of decimal places each column are required to be rounded up. And if you run it over here, it is going to give a better looking table. And if you knit it, it's going to even look much better over here, which I have not knitted over here right now. So I think this was a very short session as compared to our previous session. I just wanted to touch base again because we have not interacted for quite a while, and I just wanted to restart these sessions. I'm anticipating that we'll be running these sessions quite regularly. How regularly I'm going to do that, I'm going to announce them in a few days. But I would request you, to all of those who are watching this session live, and to all of those who will be watching the recording of these sessions, to please give me feedback on these sessions, because this feedback helps me to improve these sessions. And there is a question. So there's a question from Salima, and she is asking about so she has Salima is asking to let me read her question, and please, if you can brief PAR one more time. So let me show you, if you do not run PAR, what is going to do, and you will understand what. So I'm going to, because I've already loaded the model, so I'm going to just run this line of code only. And what is going to happen, that so there are 4 graphs, and each one of the graph is getting loaded separately, which means that you have to click and toggle around between different pages. I mean, there are 4 graphs, there are 4 pages, right? That's one way to do. I mean, that there's nothing wrong in that, but I wanted that all of these graphs should show in one page, and I'm going to use this the PAR function with its argument as mf row, and giving it a vector of 2 and 2. And what it's going to do is going to structure the graphs as an output as one. I mean, this is just one picture. If you just export it in another way, all of these 4 graphs, they have been organized in a single picture. So that's how you can make multiple graphs. You can print them on separate pages as well if you want to, but if you want the information to be condensed, you have issues related to space when you're making publication in a manuscript, or there are limitations, space limitations by different journals. Then this is one way, this is one function which will become handy in organizing your visuals. I will recommend that you Google this PAR PAR function. You will come across a number of other variants of it as well. So the next question is, what is MF in this? MF means that the number of rows. So the total number of graphs are 2. I'm going to organize these graphs in 2 rows, which means the first row will contain the 2 of these graphs, and the second row will contain the 2 of these graphs. And as if I'm not mistaken, I have to recheck, but you can also give the information in the terms to this function in the form of rows or in the form of columns, that how many columns should be there and how many rows should be there. I am hoping that this is clear, but if it is still not clear, please ask me again, and I'm going to be I'm here to answer questions if you have any, if it's still not clear. Any good book related to our programming? That's a very good question, and I'm going to that had a question. Ryan, you have asked a very pertinent question. So there is a separate series which I've already started, and I've released one of the videos, only the first video to that. What I will do is in the next video of that series, which will have 10 minutes recorded video, I'm going to talk about the recommended textbook for beginners related to R. But the short answer to that is there are many books. To be honest, I do not exactly know which one to recommend it to you right now. I will answer this question hopefully in the next video. Sanima says thank you. And with this, for those of you who have not yet subscribed to my YouTube channel, I will recommend that please subscribe to the YouTube channel, and I'm really thankful to those of you who have taken out their time to watch these sessions live. It really helps me to make these sessions interactive, and I will be also hoping from those who will be watching the recording in the sessions that they will share their feedback with me. With this, I will say bye for the night. Take care. Allah Hafiz. Bye.